That's it. The little blue bar is on. Today is Friday, the 14th of September, 2018. On the panel is Astral, Patricia, and we have Dave Marsh, and of course, Mr. Thrive and Survive. So, hello, everybody.
Hello, everyone.
Hello.
Hello, hello, hello. Good to see you all.
Hi, nice to see you all. Nice to see you again, Rich. Nice to see you again, Dave.
Yes,
and
Dave.
Patricia.
And
welcome back. Hope everything's fine with everyone.
Yes, everything's good. I've been in the wars over the last few months. I've had an ear infection where I was deaf for like 6 weeks, and I've had 2 eye infections, one in each eye. So it's been a bit of a roller coaster ride last few months, but I'm getting better now, so that's good.
Oh, sorry to hear that, Dave. But I did know that because yes, you told me. But sorry to hear that.
Dave, before you go any further, sorry to interrupt you. Anything to do with your ears, please try this before you try anything else. Clean, pure, distilled olive oil. You can get like a spray, and you spray it in your ear. And I kid you not, I always have problems with like earwax, and I don't know, it's my age. I'm a 105-year-old now. It's good. Use that distilled olive oil.
It was an inner ear infection. It wouldn't have touched it. It was actually inside the drums on the inside. So what it did, it got infected on that, and it actually forced the eardrums out. You know, like when you equalize your ears when you go underwater. My ears were like that constantly.
I don't know. It wasn't that difficult for me.
It was like having a microphone on in your head for 24/7. Yeah, it was like all you could hear is your voice all the time, but you couldn't hear anything around you. It was horrible. But like I say, it's gone down now. I've been to the hospital, and there's still a problem in my left ear, but I can hear out of it. So I've got to go back in a few weeks.
Oh, sorry to hear that.
Like I say, it's getting better now. Like I said, my eyes are cleared up now. It's not as bad as it were. Like I say, I look like Knight Rider for a few weeks.
Oh, anyway, well, glad you're here, Dave. And you,
Rich? I'm going to say, what do you mean by Knight Rider? What do you mean by that?
And you ever seen the front of the car? Woo woo, woo woo.
Oh right, okay. You look like an artist there.
No, it's just a joke. It's all right.
Hey, and what about you, Rich?
I'm multitasking at the moment. I'm uploading something real quick to tell people on my channel that I'm live now. So I might be a little distracted, but just wanted to make a little announcement. I was supposed to do a episode this past Saturday of my second episode of Saturday Night Thrive, which will be live eventually, and ended up having a few health issues over the weekend and ended up in the hospital. Thought I was having a heart attack, but I wasn't, thank God. So just wanted to make that announcement. That's why that didn't come off Saturday. And I'm glad I said in the first episode that, or one of the videos in between, that it was God willing and health, permitting, it would be Saturday. It's sort of like a freak forecast of what might come, but hopefully this Saturday I'll be able to catch up with everything and get that back started. But very glad to be here to talk to Dave about his brilliant video and the work, just absolutely fantastic work he's done with the moon. And to me, that anybody that's followed me has figured out by now that I think the moon is the ultimate smoking gun that just can't be explained in the heliocentric model. And the more we tear it down, the more, in fact, I feel like teaming up with Dave and doing experiments and things like that, because that's the ultimate tear down right there. They can't explain certain things with the moon, even simple things like how can it be silver spectrum light coming from, the sun, which is from a
coming from a chocolate chip cookie. It's a chocolate chip cookie.
Yeah, there's no doubt in my mind it's a projection. And Dave showed that in his video too.
Yes, like I say, what I did, I had like an overexposed picture, and what it did, it actually created a lens glare reflection, and the lens glare reflection actually produced an image of the moon. Now I'm trying to explain to people, this is what I believe the moon is, but on an absolute massive scale, whereas the atmosphere is acting as that giant lens. Whatever that light source is beyond there, I don't know. We may never know that, but what I can tell you, what I'm 100% sure of, is that light, what we see in the sky, is a projection, because it lights up the clouds locally, yeah, to me. But if I jump 20 miles down the road, he'd be lighting up a different set of clouds local to that person from their perspective. Yeah. And also what gives it away? Well, if you jump above the atmosphere in high altitude balloons, you'll see the moon's a tiny little dot. You know what I mean? So we're actually getting a magnified projection of the moon from our perspective on Earth. So that's my take on that. And I did a little experiment where I explained a bit like a rear projection TV. When you look at the moon in the daytime, it's a bit like watching a rear projection TV in the daytime. Yeah, pictures all fuzzy and rubbish. Yet when you close the curtains, turn the light off, and put the film back on, it's nice and crisp and sharp. Just like the moon is at nighttime. Yeah, it gets really sharp and crisp at nighttime, whereas through the day the light's getting scattered and it looks very poor quality light.
That's a very good analogy of it.
Yes, Rich, you quite liked Dave's video, didn't you? His Luna-Lema.
Yeah, there's going to be more pieces that I'm going to bring up too as well.
Yeah, like all I did, I mean, that presentation was what I put together for the UK convention. It was like half finished when I got there, and I basically had to like rush it all through to the end. And then when I did the presentation and they didn't record it live because of technical issues, I was quite disappointed. You know what I mean? So I wanted to try and get my take on things across, and obviously I didn't have the audience that I had expected to do. So then I got the opportunity to come on Karen's show and do the presentation properly. So that's when I came on the show and did the presentation properly. And then when I got ill, I thought I'd do myself like a shortened down version, like try and get it under an hour and just try and get all the key things in the video, what I needed to like show. And like I say, it's a learn as you go process. And it was probably about 70 slides when I did the presentation on Karen. It's now 83 slides, so it's constantly growing, and I'm constantly building it. I've got new star trails. I've got a new moon stream where I catch the moon on the celestial equator, traveling in a perfectly straight line diagonally. So I'm always adding to it all the time. I've even added the Go Fast rocket to it to explain some things. So I'm just it's just a work in progress, a constant work in progress, and that's what it'll probably always be. It'll never be a finished product. It'll just be keep adding to it. You know what I mean? Some things I might find are false later on, and I'll remove them. And it's just like I say, it's a work in progress project, and eventually it will be something like, but it'll never be complete.
Yeah, but Dave, that's life. That's what we're doing. We're going forward. We're finding out more. We're learning more. People like you, we love it because we're just adding to this jigsaw puzzle, and we're all fitting pieces together. You know what I'm saying?
Yeah, I think there's some strange things going to occur in the next few weeks. So what I would say is keep your eye out around about the 24th, 25th of this month, because it's going to be an interesting, because they tell us the equinox is on the 23rd, but if you look on time and date, the moon doesn't rise till 90 degrees and set at 270 till the 24th, but the actual 12 hours daylight is not till the 25th. So somewhere in between there will be the true equinox, and it just happens to fall on the full moon as well. So I'm hoping that I don't know what to expect, but according to the globe Earth model, they're both perfectly in line with the Earth, with the ecliptic. So really, how we're seeing the moon, if you go onto time and date or moon calc and put it in, you'll see they're both exactly traveling in a perfectly straight line. Yeah, so they're both in line with the Earth's ecliptic, but yeah, we're going to see the moon. So that's an interesting one as well.
Yeah. One thing I would like to say, we all know, based on years and years, you can go research years back, September 23rd. It's always 923, 923. Look in the films, 923. Russian vids, 923. The 23rd of September, isn't it? Why we're always seeing that date, I don't know, but if that's supposedly the date that the equinoxes are going to take place.
It varies. It varies.
Yeah.
What you need to do, it needs to be equal day, so it needs to be 12 hours. 12 hours day. Yeah.
That's we know.
And
sorry,
if you look
Dave,
at the 23rd, it's like 12 hours 15 minutes or something like that. It doesn't actually get to 12 hours until it actually gets to the 25th, but it doesn't rise till 90 until the 24th.
Yeah, and we know that the calendars have been corrupted. We had Dave Murphy on yesterday, and he was telling us that it's probably the Gregorian calendar that have been going off. is
Yes,
a
it
year
is.
and a half out every year. Or is it a day and a half? Sorry. A day
Well,
and a
it's a
half
quarter a day out
long
every year.
Yeah.
A quarter of a day.
Quarter of a day? No, a day and a quarter.
No, it's
I got-
0.25. That's why you get a leap year every 4 years.
Yeah, but it's deeper than that. There's more to it than that because of, we have February, 28 days, 29 days, 28 days,
Exactly.
29,
Yeah,
yeah.
I think that's personally to
So,
confuse you because, like I say, if you had
well, yeah,
28 days and 13 months, it'd be quite easy. But what they do, they like to chuck in a few spanners in the works, like, you know what I mean? So some days, some months have got 30 days, some have got 31, you got 28 days, you got a leap year, you know what I mean? You don't know where you are, really. I don't even,
exactly.
I mean, it'd probably take me like 10 minutes to work out which days have actually got 30 days in them.
What day is it today? Tuesday. Go on.
No, it's Friday. I know that for sure.
So just to confuse us then.
Well, I believe so. Like I say, why would it be so confusing like how it is? You know what I mean? Where have you got something like if you went by a lunar calendar, which would probably be around about 28 days, you'd probably work out at 13 months over 13 months over a year. Like it works out at 300. I know it works out at 364, but maybe if you, I don't really know, but I know the Enoch calendar was like 364 days, but that was a day out as well. So, but I'm sure if you took all the seconds and divided them by a certain amount of numbers, you'd get the right amount of months, and you know what I mean, over the time.
They changed the calendar, didn't they? Gregorian, is that it? Gregorian.
Yeah, we use the Gregorian calendar now. We used to have a Julian calendar. We've had all sorts of different calendars throughout the years.
So why do you think that they put the different days in there then? If everything's very precise and runs to a table, basically, why would they put all the days in there to mess it up?
For confusion. That's what I think anyway. That's my personal take on it.
Definitely confusion. They do not want us to know. They don't want us to know because those books, and believe me, there is some sort of I wouldn't say King James version of the Bible, an older version of the Bible that the powers that be read into, and they can see when this is going to happen, when that's going to happen, and when that's going to happen. And like Dave Murphy said yesterday, these events that are happening now, they know these events are happening now. They've known this for so many years. They've predicted it, they've planned it, and that's why we're getting all these, it's geo-engineered weather, isn't it? And they're trying to hide something from us that we're not allowed to see in the sky so that we can ourselves work out what exactly is going on, where exactly we are in the sky calendar. It's not a calendar we need to see on a piece of paper. Our calendar is a sky calendar. That's the only calendar we have. I yield the floor. Sorry.
Yeah, I believe that they're also trying. I don't know whether they're hiding more land as such, but it's quite strange that the furthest you can go without a permit south is like 55 degrees to Ushuaia in southern Argentina. Anything beyond that is like you're entering the Antarctic Treaty. So that's quite strange because in the north we can go to Svalbard in Norway, which is up at 78 degrees, which is a hell of a lot further north than we can go south. So it is strange how there doesn't seem to be anything beyond 55 degrees apart from Antarctica. So that's interesting to look into as well.
Have you heard that there's a group of scientists going with flat earthers to the Antarctic, supposedly? I don't know the details. I just happened to see something the other day about it, that somebody's gotten a group together.
Was it me that sent it to you, Rich?
It may have been.
He's coming on Sun and Moon next week.
Oh, is he? Awesome.
I just saw him and I just thought, right, let's just talk to you then. And he agreed to. He's already organised. They've got it already. They just want volunteers. But he's not going to say where they're going to go. Like to start with.
That's right. You did send it because I didn't understand what he meant by volunteers.
Well, you have to remember, going to 60 degrees, to the foot of Antarctica is not really getting anywhere, is it? You know what I mean? At the end of the day, you need to be going as far as the pole, but you're not going to get nowhere near there because remember the Robert Short? Is it the Antarctic plumber who worked there for 2 seasons. He's been on Anthony Subrat's show a few times. And he says whenever they left the base, it was always with a guide, and no one went anywhere near the American base while he was there, and he was there for 2 years. So, you know what I mean? They might just take you to the shore, see the penguins, and then
Yeah, well, it's almost apparent that whoever goes down there, you have a limited like vicinity that you have to be within. You can't go beyond that.
Exactly.
If you do go beyond that, you're going to probably get shot, or hey, get back here now, otherwise you're going to get shot. You know, it'll be something like that. If there was a possibility of someone doing something, could it happen? What I'm saying is this: could it happen? And I say, of course it could happen. We could get 1,000 people over. We could get 1,000 people easily, and no one would see us. You think about how giant, how immense the size of land is, and how much area they have to control, right? How many people are down there? Work it out. Work out the numbers. And if you've got a person, you know, hand to hand or linked to arm or whatever, it's a lot of people that you're going to have to surround the whole thing. And I know they've got like radar, and they've got you know, different things to find any kind of construction or whatever. Hey, but you can find materials. They're not even going to be registered with radar. We've got these stealth fighters, haven't we? They can't be picked up by radar. You know, we've got plenty of smart people. We can build a sort of toboggan that cannot be picked up by radar. It can be made out of
Astral.
different things.
We're supposed to be doing Mr. Thrive and Survive with Dave and the Luna-Lema. Silence.
yeah. Anyway,
All right, I'll be quiet now.
while we're talking about the equinox, what is interesting as well is during the equinox there is another phenomenon what takes place called a lunar standstill. You may have heard about it. They call it a lunar standstill because basically the moon makes big leaps and it looks like basically the Earth stands still, but we know that the Earth standing still. So basically, I'm renaming it the lunar jump, because what happens on the autumn equinoxes, whereas the moon normally rises 50 minutes later each day, well, over the equinox it actually rises 20 minutes earlier each day. So it makes big leaps north, obviously, because it's rising earlier. But if you go further north to Svalbard, the moon is rising less than 24 hours than a day. Yeah, just think about that. Yeah, the moon normally rises 24 hours and 50 minutes meantime, and it's in places like Sweden and Norway, it's rising less than 24 hours each day over a 3-day period. Look it up on time and date. You'll see. Go to somewhere like Svalbard in Norway, and you'll see massive jumps from the moon north, which is quite interesting.
Hey, Dave, can I clarify just for some of the comments I got on my video? Maybe I should not have shown the race you had on there, because I think it led to a little bit of confusion. But let me make sure I've got this right. And for people that are watching who saw my video, what you observed was, and correct me if I'm wrong, that the moon at apogee was speeding up, and also the moon at perigee was speeding up, and I take it that in between the two was slowing down. Is that correct?
Right. What I did first time round, when I first did the experiment, and I started with the moon high on the Tropic of Cancer, when the moon was in there, it travelled to like say an average speed, but when it moved to the equator, the moon actually speeded up. Yeah. So say it took 24 hours and I don't know, I think it was something like 58 minutes to occupy the spot on the Tropic of Cancer. On the meridian passing, where I'd seen it speed up on my screen, and where I checked the actual meridian passing time on that observation, the moon occupied the same spot in like 24 hours 42 minutes. So it's getting to the same spot quicker, so that tells me that it's speeding up. Then on the Tropic of Capricorn, on my third observation, the moon took longer, and it took around about 24 hours, 52 minutes. So it's actually slowing down when it's on the Tropic of Capricorn. Now, when I first originally looked into this, I wasn't looking into the lunar anomaly or the animalistic cycle, which is where the moon will be at its furthest point, at apogee, and its closest point. Luckily, the moon just happened to be in that part of its cycle in regards to the actual lunar cycle, if that makes any sense, because the actual cycle of the moon is 27.3 days, the animalistic cycle is 27.5 days. So they stay at relatively the same position for quite a long time, and it takes quite a bit of time for it to actually go out of sync. So luckily, the actual point of apogee was when it was on the Tropic of Capricorn, and the point of perigee is when it was on the Tropic of Cancer, which it still is. Now, from a globe Earth perspective, it's quite hard to get your head around this. When the moon is at apogee, from a globe Earth perspective, it should appear to speed up in the sky. Imagine being on a roundabout and a moon's walking around with you, then it slows down. It will look like it's actually speeding up in the sky, yeah, because the globe Earth is supposed to be spinning. So you imagine from that perspective, yeah, it would actually appear to speed up in the sky. They tell us it speeds up at perigee, but that would actually slow down in the sky and look like it's actually retrograding a little bit, yeah. But because I've measured that meridian passing over a full year, I've seen that the moon actually, when it speeds up, it's not a gradual speed up to apogee or a gradual slowdown to perigee. It's actually, it jumps up in a very sharp time. So it goes from its like lowest velocity to its fastest in like 5 days. Yeah. So it'll go from say 24 hours 58 minutes to occupy the spot, and within 5 days it's already there at 24 hours 42 minutes, you know what I mean? And then it starts slowing down again. So it does it in a very sharp period, which doesn't fit Kepler's law, because as you know, it should spend the first half of its cycle speeding up to the point of apogee, and then spend the second half of the cycle slowing down. And what I did with the second lot of observations, I started, because I realized that the moon was at apogee at that point by then. Yeah, it was just a coincidence first time round, but luckily second time round when I did it, I was actually looking for when it was at its furthest point. That's why I used NASA's lunar reconnaissance to see when the moon was actually at its furthest point in their model. And like I say, there was not much of a relative change in speed from when it goes from Capricorn to the equator. It was only a very, very short, well, you know, it's only like I think it's what is it? It took about 24 hours. I don't know if it was 48 minutes somewhere, and it took 49 minutes when it was on Capricorn. So it only speeded up slightly, but that even though it only speeded up slightly, it shouldn't have speeded up going that way. You know what I mean? We should have expected a decrease in the speed as it gets to perigee, where it speeds up. So what I did, I observed the moon speeding up, yeah, by making 2 observations, by letting the moon pass my screen, and I also backed up by the meridian passing on the time of the observation that actually proved that the moon was speeding up at that point of its cycle, because I made 9 observations and every single one of them matches up with the meridian passing. So when the moon appears to speed up on my screen, the meridian passing time is shorter. When it takes a long time, like it took 24 hours 57 minutes, it took like nearly 6 minutes to cross my screen that night. So what I'm observing matches that meridian passing. Does that make any sense?
Yes. Dave, can you define for people who may not know what apogee, perigee, and meridian crossing is? And also, after that, have you taken into account possible, let's just assume that the globe model was correct. Could the Earth's position, its tilt, its position in the sky at a certain time of year have any effects on what you observed?
It can't do. It's impossible. It can't fit the globe for the simple reason, yeah, like I say, if it was an elliptical orbit, then like I say, we should be seeing a gradual change in speed and not a short, sharp shift, if that makes any sense.
So you're saying it was a 5-day cycle?
No, I'm saying the moon, the change in velocity, yeah, happens in a very short,
okay,
in a very short time. It's not a gradual. It should be like half of the cycle we'll see a gradual increase in speed, and then for the rest other of the cycle, a gradual decrease in speed. But we're not seeing that. You see a real short, sharp shift. Yeah. So basically, when the moon's at perigee, and it moves to like a neutral position, you'll see a gradual increase in speed. Yeah. But that changes then from the next point of its cycle. Yeah, it's not like a gradual change. Like I say, it speeds up short and sharp. And if you look at the meridian passing, it basically goes from its like slowest time to occupy the same spot at the meridian passing or the culmination to its quickest in I think it's like 5 or 6 days. There may be something else in that. I don't know. I mean, all I've done is try to look how the ancients recorded the lunar animalistic cycle, and to me, that is the only way you can actually record the speed of the moon, by looking at that meridian passing to see when there is actually a change in time for it to occupy that same spot. So in regards to the meridian passing, my meridian passing or my zenith point is always 180 degrees south. In fact, it's 180 degrees south for the majority of the people in the Northern Hemisphere. Yeah, that is always your point at zenith. So if you go on to like time and date, what they'll tell you what time the moon's at zenith. All I do then is look on the following day to see what time the moon's at zenith that day, and I measure that time in between. That gives me a measuring tool. Yeah, and that's all I've done. I've just measured that meridian passing over a year to see when the moon speeds up and slows down its cycle, because there is no other way that me, as a person sat here in the middle of the UK, can observe any other way of observing the speed of the moon unless I can use that meridian passing as a measuring tool.
Dave, can I ask you, when you say zenith, when the sun is at its zenith?
Well, they call it the solar noon for the sun. It's basically when it's at its closest point to the observer. Okay,
but hang on, what's the difference then between zenith and meridian? Because I've always gone, meridian is like when the sun is at the highest point in the daytime.
It's the same thing, really.
Well, why do they have two different words, zenith, meridian?
They have culmination as well, you know what I mean? There's probably a dozen words for it end of the day, you know what I mean?
No. Dave, seriously, why do we have two different words for the same thing? And it's two different, meridian. It's not like we go and say meridian like 8 times a day, do we? We don't probably say 8 times what we do. Most people will not say meridian 3 times in a lifetime.
I do.
Most people, yeah, we're different, Dave. But most people will not even say zenith maybe twice in their lifetime, or even once.
Quite often too.
Seriously,
yeah, because when I'm referring to the moon being a closest point to me, I refer to it as being at zenith. It's just easier for me to, you know what I mean? That's just the word I use. If I kept saying closest point all the time, you say, what point's that? So I'll just say zenith. It makes more sense, and people probably understand that more as they go along anyway. So yeah. Zenith is just the closest point to the observer, and my zenith is always 180 degrees. If you're in the north, it'll be you'll be facing north at 0. Sorry, in the south you'll be facing north, and that'll be the zenith there. And like I say, I've always, to keep my observations consistent, I've always used that point at zenith as a marker, because obviously, if you're measuring the moon, the best time to do it is when it's at its highest point or its closest point. If I did it when it was rising on the horizon, it'd be massive all the time. Then you know what I mean. Then I'm not going to get a consistent measurement, because I'm doing a little experiment now where I've actually caught the moon at the point of apogee on the day. Yeah. At zenith, and I've also measured it across my screen. Now I'm just waiting for the moon to get to a decent position at perigee, because at the moment it's too close to the sun. So in a few months' time, when the moon's at perigee, I'll measure it again, and I'll see if it's actually getting bigger. Because for me, if it's high on the Tropic of Cancer, I'm going to be looking at it through less layers of atmosphere than it is when it's low on the Tropic of Capricorn. So I can't see how it's going to get bigger, because in my first experiment, when I measured them at 1414 millimeter, equivalent to like a 35 millimeter lens, it was actually smaller on the Tropic of Cancer, where it should have been bigger. So it's quite difficult to measure the size of the moon as well, because of all the different changing atmospheric conditions. So you imagine some days when there's more moisture in the air, that disk will appear slightly bigger. If you've got a nice, really dry evening, then that moon will probably appear smaller. So it's quite difficult as well. And I've tried to explain this in my presentation, that to actually get an accurate measurement to see if the moon is actually bigger at perigee is very difficult because of the constantly changing atmospheric conditions. So unless they have another tool to measure with, I don't know, but I'm just going what the tools I've got.
Yeah, and if you don't have any clouds.
Well, yeah, like I say, I mean, we all missed the biggest event ever, the lunar eclipse, didn't we?
Yeah.
In July.
It's cloudy here.
Yeah, but luckily there's another one coming on the 21st. I think it's the 21st of January, if I'm correct.
If I'm not incorrect, they come about every 18 years, don't they? Dave,
you'll get them. Like, I mean, obviously there's one in July. There's one in July, weren't there? And there's another one in next January. So they do, and this is like a total eclipse as well.
I had a little eclipse here about 3 weeks ago. Yeah, and about a month ago there was also
I think that's the one Dave's talking about.
There was a blood moon eclipse, a lunar eclipse.
That's what I'm on about.
There was also another one here after that.
There always is.
But about 2 weeks ago there was.
There's always a solar. There's always a solar eclipse after a lunar eclipse, normally. Yeah.
Or you could be like Joe Hill. He just got a shadow.
Dave, I want to ask you because Rich asked you also. Perigee, apogee. That's when the moon is furthest away. Am I correct? And perigee is when it's closest.
Yes.
Okay. Just explain that to people that are in the chat, because there might be a lot of people that are not aware of these. We're into this all the time. We know.
Well, according to Kepler's law of planetary motion, an object like the moon or the Earth will travel around another object in what they call an elliptical orbit. Yeah. And we'll take the moon for example. So the Earth is in one focus of the ellipse, but there isn't a second focus point because that focus point apparently is mathematical. I don't know how they get a mathematical second focus point, but that's for another time anyway. So what happens is, as the moon approaches the Earth, it will speed up, until it passes its point of perigee. And then as it heads towards apogee, it will slow down again, and will do that constantly. So that's basically how Richie probably can explain it better than I can, but that's basically it. So they're saying that the gravitational pull is obviously a lot stronger when you're closer to the globe Earth, so that will cause it to speed up, and as you get further away, that gravitational pull will be less, so it will slow down.
The gravitational pull, what's all that bollocks for nothing?
Well, that's according to the heliocentric model,
which I think your video destroyed. Yeah,
like I say, it's like I said, the first thing I looked at is when I looked into Kepler's law is an ellipse needs two foci or two focus points. If they show you a demonstration in a physics class, what they'll put two nails in a piece of wood. They'll get like a piece of string and a pen, and they'll drag it round, and that's how they make the ellipse. Now the problem is, if you look into the Kepler's law of planetary motion, there's only one. It's only the sun or whatever object is that occupies that one focus point. So when I ask the question, so where's the second focus point? It's mathematical. It doesn't exist. It's just a mathematical point. Now that should destroy the ellipse straight away, but that doesn't matter anyway, because the sun is supposed to be in apparent motion as well. So now you imagine the sun being in motion. So you're at a point, and that sun has moved, and that Earth has followed it. Yeah. When that Earth gets back to that point, it's not going to be in the same spot. So instead of having elliptical orbits, you're going to get cycloidal orbits or springs. So having the sun in motion, which happened after Kepler's law, which I think William Herschel was responsible for putting the solar system into motion, that in itself destroyed the ellipse as well. But even so, you can't have an elliptical orbit without two focus points. And they always say, the sun is in one focus of the ellipse, but they fail to mention the second point. So that to me is like a failure, a big failure. Yeah.
The other thing, Dave, is I know the moon is on, what is it, an 18.6 or 19.2 year cycle also. There's a lot, as you pointed out, there's a lot of different cycles.
Yeah, there's a Saros cycle, which is like the 18.6, which is related to eclipses. So basically, to get the same eclipse at the same time, it will be that 80, I think it's 18.6 years or something.
So in other words, if you had no model at all that goes along with NASA, if you just thought it was a flat Earth, every 18.6 years, if somebody was taking careful observations, they could tell when the next eclipse is going to come by, correct?
Correct. That's how I believe Alex Gleason worked it out.
Yeah, and that's how NASA worked it out too.
They've always been able to work out eclipses, and I saw a video years ago, and it was about, it was about 18 years. I know it's now 18.6 or whatever, but every 18 years or something, you're going to get one of these eclipses, and they do follow a pattern for sure.
Yeah, and that's when you're supposed to get a lunar standstill. Sometime in that Saros cycle, there is apparently a major lunar standstill. I'm not sure when it is, but I've been looking for it actually, but I can't seem to find out exactly when this major lunar standstill is supposed to take place. But I do know that the minor lunar standstill takes place between the 23rd and the 26th of this month. So that'd be good to look out for.
Also, Dave, you've got the next 100 years of moonrises.
I did have, but I haven't got it no more. I got them off Steve Torrance.
Yeah,
I haven't got them no more. I did have
100 years. How do they know?
It's just a mathematics. It's just it's all maths, isn't it? You know what? Once you've got the, you know what I mean. It's just a cycle. You know what I mean? Ptolemy was predicting eclipses and all celestial phenomena back in the 2nd century. You know what I mean? His model was like it stood for like 1,400 years. You know what I mean? It was the perfect model at the time, and that was based on a geocentric Earth. So,
hey Dave, where I was going with that question is that was sort of the setup. Supposedly, you know, you get all these, if you want to find out how far the moon ever deviates from the equator, you get all kind of confusion online. You get, it's 5 degrees, no more than 5 degrees plus or minus from the ecliptic of the Earth.
Yeah, between 18 and 19 degrees from the equator, it'll deviate. And it'll fall short of 5 degrees, whereas the sun will deviate 23.4 degrees from the equator. From a flat Earth perspective, the moon will rarely go past 19 degrees. So it falls short of 5 degrees, and that's where the globe model has inherited the 5-degree inclination, if you understand what I'm saying. Yep.
That makes sense now. Okay.
Yep.
Now, have your observations, or have you even looked at that to see if you get that much of a deviation?
Have we just lost somebody?
Hello?
I'm back.
I
think we lost somebody.
Can you hear me?
I'm here. Oh, it was,
oh, you're back. Something
broke up.
Something broke up. Can you repeat that? I missed it.
Yeah. Have your observations shown? Let's say after keeping track of how far north you are, since it's supposed to be tropics. Have your observations matched what, let's say, says where the moon? I should say, time and date. If time is it's 14 degrees north of the equator, and then you do another observation and it's supposed to be 14 degrees south of the equator, then do you find a 28-degree difference in the side that matches?
Every observation I've made usually matches up with time and day. I don't particularly use time and day. I use moon count, but nearly every single observation I've made using Dioptra app, the moon has always been within like 2 degrees, whether it's the azimuth or the actual declination angle. I've never observed the moon being in a different position where I've actually observed it. And I do know that the Dioptra app is pretty accurate because I've laid it over my compass and it's probably about half a degree out, but there is a slight declination in the UK, so that could have a adverse effect on that. But normally it's where I point the app, If I look on time and date or moon calc, it's in the relative position. It's probably me who's probably a little bit out, you know what I mean? Because I'm holding this app up to the moon, you know what I mean? If I just move a little bit to the left, it's a matter, it could be like 5 degrees, or it could be a declination angle drop of 5 degrees. But relatively, I mean, my first observations were like 7 degrees out. But as I went on and I'm learning more new techniques, holding my breath when I'm taking like a snapshot and things like that, yeah, you learn to get a little bit more accurate. Because what I'm doing, you see, I'm trying to get my readings as accurate as possible. Yeah, because if you've got a big gap in your readings against mainstream, all I'm using mainstream for is to see, yes, the moon's in that position. Yes, my readings are pretty accurate. To say I'm not using it from a globe Earth perspective. Any doubt whatsoever, I'm only using it for the moon direction and the moon angle. That's all I'm interested in. So does that answer the question? Or
Yeah, and I think it's fantastic that yours matches, because when your data matches like moon calc or time and date, then those same calculations show that Kepler's law doesn't apply to the moon. To me, that's like a double blind verification that what you're doing is correct. What your
yes,
conclusions are.
yeah, like I say, it's you know what I mean. Then you have to understand about all Kepler's laws were built on the back of observations that were made by his predecessor Tycho Brahe. Now, this was before the telescope was invented. Yeah, the telescope wasn't invented when Tycho Brahe made his observations. The telescope wasn't invented when Tycho Brahe made his observations, and all Kepler's laws are built up on the back of them observations. So it's not a really good building block for science when you haven't even got a telescope, because all the observations were made in the early, was it the late 1400s, and the telescope weren't invented till the beginning of the 1500s. So it's not a really good building block for science, is it?
Observations of what?
Mars.
Oh my.
That's what Kepler's law, that's what I tried to explain in the video. Yeah, even though, yeah, Kepler's laws were all built on the back of observations before the telescope was even invented.
How sad, and this is settled science.
Yeah, and they haven't changed that law, yeah, since what, the 1500s, which is absolute nonsense. You know what I mean? With all the technology and thing we've got now, we should have it. Because what you do, you look at all the ancient recordings and results, yeah, then you look at modern day, there's about 0.0002 degrees in it, you know what I mean? There's never like a massive, oh yeah, they got it really wrong back then, you know what I mean? They always seem to get it right back then, and we're living off everything we live off, we learn is all from the ancient stuff. They knew that years and years ago. We're not learning anything new from science today. I'm learning all my stuff from old books. I'm not reading modern science books.
Exactly, Dave. I would love to add to that. We seem to have got stagnant, not us particularly, not you in particular, but society in general has got like stagnated, because we just take everything for granted now. It's like, no, we figured that out, man. We know that. We know that. We know that. You know what? We don't know anything. We know shit. And that's why I love you, Dave. I love you, Rich. Everybody, all the people in the chat that are looking into things, you know, we have to find the truth, and that's what we're doing. I just want to say, Dave, there's a question from the chat here. Does the moon really speed up? It's from Sidi El Kachi. Does the moon really speed up, or is it a matter of perspective if it moves closer to the Earth?
Yes,
that's the question.
That's a good question, and that's the question I got asked after my first moon race video. So what I did then, we know that time and date's accurate, so I went onto time and date and took readings for when the moon was perpendicular with that point. So for example, when the moon was over the equator, I went to somewhere on the equator and I took the readings and measured the meridian passing on them the nights of my observations, and the times are exactly the same. There's no change. The moon's not slowing down because it's further away and it's a smaller object, because if you go to the point where the moon is perpendicular with that observer at that point, that time, yeah, and you measure the meridian passing from that location, guess what? You get the exact same meridian passing times you get in the UK. It speeds up at the same point all across the plane. It doesn't matter where you are. And I showed that, and that's why I did all my readings from 3 separate locations and not just my location. We know that time and date and moon calc's accurate because I proved that by making my own observations. So we can rely on it when we go to places like Ushuaia or Pontianak on the equator. Now that's how I did it, and like I say, I can trust time and date and moon calc for the azimuth and the declination angle, and that's all I'm using, that meridian passing, for when the moon is at 180 degrees or 0 degrees, depending on what side of the equator I'm on. Yeah, and I just measure that meridian passing time, and they all match up across all my observations to the minute. There is like a slight difference in time, but you have to take into consideration like Pontianak is quite far away as well, so there's a little bit of a time difference. But if you look at the actual graph side by side, it's relatively the same. So the moon is speeding up from everybody's perspective when it does speed up and when it does slow down.
Thanks for that. I was just going to say that what you said, you trust timeanddate.com. Why do you trust them?
Because I'm only using it for the azimuth and the declination angle. And every time I've measured that, Karen used to have a group where we just used to take readings all the time.
Yeah.
Every reading I've ever taken, I've always compared it with moon calc or time and date to see if my readings are accurate. Even though I've only
correlated.
even though I've only made 9 observations a year, I've made thousands of observations and checked it with time and date. Thousands, you know what I mean? Every time I used to see the moon, I used to take my app out, take a shot, go on to moon calc, check it on there. Is the declination angle the same? Is the azimuth the same? Yes, it is. Move on. I've done it hundreds and hundreds of times, and 9 out of 10 times it's within 2 or 3 degrees. It's usually me. The reason why it's out, because I can't hold my hand steady enough, or I can't get the moon. You know what I mean? When it's quite high up and you're bending your back and you're looking up, it's hard to get that little dot in the middle of a crosshair.
Yeah.
So
I know what you mean. I'm trying to photograph the moon at night, and it's got, you know, when you try and photograph something at night, dark, you have to hold your camera still, and it's shaking like a dog having shit.
You just buy a tripod.
yeah, exactly. But I don't have one. But
I just want to make a little disclaimer here as well, because Mike Helmet tagged me in something the other day in regards to seeing stars through the moon. Now, I don't support that theory, because I've shot the moon on a number of times, and I've seen Aldebaran go behind the moon, and it doesn't appear until it comes outside of the shadow part. Now, I know Mike tagged me in that, but I just wanted to say I don't support that theory at all, because every time I've seen a star, it goes behind the moon. And if you see my recent moon shot where I actually overexpose the dark side of the moon, yeah, and you can see that the moon is actually still there. So I don't support that theory, Mike's.
I've put your video of that star. It caught the moon up, and then you don't see it till it comes out the other side.
Yep, I found it at 4 a.m. over 2 hours.
Yeah, but how do you then? What do you say about? We've seen the sun. We've seen the moon, half a moon, where we can see. No, we can see through the moon. How does that happen?
Today it was like that.
Yeah, it looks like it when in the daytime it looks like it, yeah, because obviously the light scatters and you can still see the blue sky, but you can't see anything through the moon, even when it's like a very small crescent moon. You look at go and look for any occultation.
I have to disagree, because we are seeing what we're seeing, and if you see through the moon, you see through the moon. I'm looking at the moon, and it looks like I'm seeing through the moon.
Yeah, it does, because the light scattering.
That's my own perception. And I know what a circle looks like, and I know what half a circle looks like. Well, if I've got an image of a circle in my head, I can see half a circle. Imagine the other half of a circle. How can I see? But don't
forget, Astral, it's a chocolate chip cookie up there.
It's something, that's for sure. Anyway, right. I'm going to yield the floor.
What I'm going to do now, I'm just going to share the screen and just show you something. What I took the other.
I'm just going to put it on someone else, though, Dave.
Yeah, put on somebody else for the time being until I can get my page up. Because I just want to show you the shot I took. Because you'll probably understand better when you see the shot. Then you can tell me how somebody can see through the shadow part of this.
Right, I'll put it on Patricia.
Right.
In anticipation, waiting.
Yeah, I'm just scrolling down. It's surprising how many posts you do, isn't it? You don't realise until you scroll down.
I'm sure Rich has got a few more questions for you, or things he wants to ask you or say, by the way, as well.
Right, here we go. Right, can I share the screen now, can I?
Yeah, it's on Patricia.
Right, see if I can remember how to do this.
Just go to application.
Yep. Application window.
Yeah.
And share.
The page you've got open with what you want to show.
Right, if you just put it onto my page now. Do you see that? You see that moon?
Yep.
Well, obviously that is a waning crescent moon at 9%. Now you tell me how you could possibly see anything through that moon.
You can't. I'm saying
Can't.
in the daytime. Daytime.
Yeah, because the light's scattering it.
When the sun's in the sky, the moon is in the sky. You can see in the morning the full moon. You can see stars through the moon.
Well, I've been observing the moon for the last like nearly 3 years, and a hell of a lot of my moon buddies have, and none of us have actually seen it or witnessed it. And there's quite a few of us who recorded it. Cass Kring's another one who's recorded it. He's recorded it on a few times. I'm going to stick to my guns and say I've never seen a star go in front or been seen through the dark side of the moon ever.
I would have never believed it really, except for I know it was in the, I believe it was the 1800s, 3 different mainstream scientists. I think one was at the Royal Observatory in London.
Yeah,
in England somewhere.
I did comment on that as well, because I said, yeah, and they actually believe we still live on a globe as well. So,
well, and then I've seen other people photograph stars in the dark part of the moon or through it. So I think what it has to be is conditions have to be perfect for it. But I think it is possible.
I'll stick to my guns
That's
until
fine.
until I can see it or observe it, and even close friends who would do, then I'll agree with it. Until then, and I've been filming the moon a hell of a lot, yeah, at different times of the day, evening, dusk, dawn, 2, 3, 4, 5, 6, 7, 8, 9 in the morning, and I've never observed it ever. So
Dave, have you never seen a star where the moon ought to be in the daytime? In the body of the moon where it ought to be. You've never seen a star shining through the body of the moon where it ought to be, but you can't see it. You can just see blue sky and a crescent moon to either the left or the right, waning or waxing.
yeah, but then when you learn about light scattering, then you understand why you see the blue sky through the moon.
Yeah, but what I'm asking you is, have you never seen a star where the body of the moon should be in the daytime? Because I have.
Well, I haven't, because I've never seen a star in the daytime.
Like in the morning.
Right, in the morning, yeah. Well, let's just leave it at that, because I will stick to my guns until I've observed it. And like I say, and I've got some very, very good friends who are.
Can I ask you something then, Dave? Okay, you stick to your guns, but what do you think it is that they're seeing then when they show those pictures with what looks like? What is that then?
It could be lit pixels. It could be anything. Yeah. What a lot of the people do as well, if they stack an image of the moon, yeah, you will see little white dots through it. Yeah, and quite a few of the images I've seen look like the moon has actually been stacked. That's why you can see the little white pixels through it. Like that. If you've got one white pixel out on your camera, yeah, it will pick it up if you stack it like that. It'll make it like a white look like a star. But like I say, I've got quite a few friends, Ali Madge, Jenna Fredo, Cass Kring, Alex Correan. None of them have ever observed it, and I haven't observed it either. So
Okay then, thank you for that. Thank you very much. Rich?
Yes. Dave, do you have an infrared camera or an infrared lens?
yeah, I've got the infrared lens, but you know that all the cameras have got a little chip inside them, so you don't have the full spectrum light, access to the full spectrum light. But I've got an infrared sensor, yeah, infrared lens.
Have you ever used that on the moon?
Yes, I have. I've shot the moon in infrared.
What does it reveal?
It looks exactly the same, but in a different color. See, but my camera's not got the actual full spectrum conversion, so I can't really comment on that. what I would suggest is you probably look around for other people. My mate Ron, I can't remember his second name. He's got the infrared camera. Like I say, I've got the infrared lens, but without that chip being taken out and having the full spectrum conversion done to the camera, which is really expensive, then I won't see the moon in full infrared.
Do you happen to know if ultraviolet is available?
When you have a full spectrum, mate, you've got the full spectrum. You can have any lens, you can have any filter you want on that, whether it's ultraviolet. You can have all sorts of different lenses, H alpha, infrared.
So it's just a matter of getting the camera with the chip to block it.
Get the blocking chip removed and have the camera full spectrum, but then you'll need a different filter for every different kind of occasion, like.
So it's like you have to have you have to almost trash your camera just to use it for science.
To do it on your own, if you get one speck of dust in the camera, it can damage it. You have to have it, you know what I mean? There is a conversion kit to get it done yourself, but I wouldn't risk it on like a P1000 if you just paid £1,000 for it personally. But you can buy them already with the full spectrum. You know what I mean? They're a little bit more expensive, but you'll probably be able to pick a second-hand one up off eBay. But that is definitely a way to go with the cameras next, full spectrum. And I think if I do ever invest in a new camera, I'll get my old camera converted for the full spectrum.
Now, infrared, I don't know what you have, but doesn't infrared pick up the heat of an object?
I'm not. I thought it just filtered out the actual spectrum, the light spectrum.
Okay.
Yeah, it's nothing to do with the heat. I think it's just the spectrum of light. What you know what I mean? You can see that spectrum of light.
If you imagine, Rich, when you change channel on your remote control, that's using infrared. It's light we can't see, but it's there. And then we have the opposite end of the scale, ultraviolet, another part of the spectrum we can't see. But infrared, we can manufacture it, you know, with cameras and shit. You know,
yeah, I've got an infrared sensor in my phone. My phone comes with an infrared sensor. I can actually use it to control the TV remotes.
Wow, it's crazy, isn't it? You only need your phone for everything.
Yeah, you do these days, don't you? Laptop's obsolete.
And you were saying earlier on about Kepler's law that Rich has put a video out as well.
Yeah, I watched it. It was good. Yeah, like I say, it's what I wished. I don't know if you can remember, Rich. Last time we was on the show together, I was talking about putting this actual video together, and I was basically giving a shout out if anybody wanted to support me or give me help to put it together. You know what I mean? Because it was a mammoth task at the time. You know what I mean? I was obviously living in Ripley. I had a family, a full-time job, which I still got the full-time job. You know what I mean? I'm working full-time here, so I only had a very small time to like get things done or make observations. You know what I mean? So it was difficult to try and get it all put together, but to do it all on my own was like a mammoth task. And if it weren't for the actual convention, I would have probably never put it together. It was only that what driven me to put it all together, because I knew that, you know what I mean, when you've said to somebody you're going to do something, I don't like to let people down. So it got to like February time, and I hadn't even started the presentation. I had everything on the computer ready for the presentation, but it was just a matter of putting it all together. So then it was like a job and a half to try and put it together. And like I said, when I got to the convention, my presentation weren't even half finished. I basically had to rush all the end bit, you know what I mean, just to try and get a conclusion to the actual thingy. And then I went back and obviously and I went through it and did the changes to it what I wanted to do, and I had it because I wanted it to be under an hour. You know what I mean? I included a lot of things like Brian Cox saying that no one ever believed that the world was flat. Yeah, but then obviously we just have to look at every single ancient cosmology, you know, and every single one of them depicts a flat Earth. So, like I say, it was a tough time, because I went through a breakup with my relationship at the beginning of the year as well. So it was a really tough time to like have to go and do a convention, put a presentation together, and you know what I mean, pick yourself up basically from being down. But like I say, if it wasn't for the convention, and you know what I mean, that gave me the drive to get my arse up and get into gear, I'd probably still be sat on the settee moping about it now.
Well, I'm glad the convention was there then, because it's fantastic work.
Yeah, like I say, it's you just concentrate on one aspect of something, you're going to improve. And you know, like I remember you saying, Rich, that one person, you know what I mean, if you bang your heads together, then you'll always probably get something more out of it. I think you remember saying last time he was on the show. I think it was about a year ago now. But like I say, I've been banging heads together with people online all the time. You know what I mean? Putting scenarios to them and asking questions, and they're asking me questions, and we're asking each other why is this, do that. Interestingly, just gone on the last eclipse. I noted this before, and this is really, really interesting, because when you watch the moon, when it waxes and wanes, at different percentages per day. So like from a crescent moon, it might wax like 7 or 8%, but as it gets to full moon, it starts slowing down, and you only get like a 1% or a 2% increase in the actual waxing of the moon. But interestingly, on the January 21st eclipse, now, if you look at that, the moon is 100% for 9 hours. Now, how the hell does that fit in with the heliocentric model to have the moon full at 100% for over 9 hours? If you don't believe me, go to MoonCalc, put in this, January 21st, 2019, and you'll see a full moon for over 9 hours, a 100% full moon.
Dave, I just want to say your observations are amazing, but what you're failing to realize is you're comparing your observations with something that is pseudoscience, and that's bollocks. You're comparing your true analysis and your true readings and your true what you're seeing, what you're photographing, what you're recording. This is reality, compared to something that you have not got a clue who. I mean, it could be a Muppet that's just uploaded that shit, man. Understand me correctly, what I'm saying is now, you have done what you've done, and you've seen what you've seen. You've got your own research that you've been doing for years, and I know that you're tenacious in what you do, definitely. You go to it. We all do. We want to know.
Okay, then I'll ask you a question. I'll ask you a question. How would I be able to find the direction of the moon without?
Brother, I want to say, why are you trusting pseudoscience over your own observations? Dave, you're the man.
Yes, I know. Because I'm only, like I said before,
you're finding the truth, and
I'm not using anything from the heliocentric model. All I'm using time and date and MoonCalc for. And if you look at MoonCalc, it's actually placed on a flat map, and it's actually the moon that moves around on MoonCalc. Yeah, so that tells me they're using a geocentric model to start off with. Yeah. And so they're using the moon over a flat map. So to me, it's not really a globe model when they're showing you a flat map, and it's actually the moon that moves on MoonCalc and not the actual land itself, which would be the case if it was a heliocentric model. So MoonCalc itself is geocentric to start off with, yeah. And all I'm using it for is the azimuth and the declination angle. That's all I use it for, yeah. Otherwise, I'd have to learn to use an astrolabe. Yeah, which means probably digging up Ptolemy's Almagest and trying to find out how to construct and use an astrolabe properly. It's a lot easier to use today's technology. Yeah, why shouldn't I use their technology against them as well? You know what I mean? Because like I say, I'm not using anything to do with the globe. I'm just using it for an azimuth.
Well, I do know that when Robert Force uses his apps and it says the moon's going to appear at this time, it always does.
And yes, it does. You know what I mean? And like I say, you have to rely on some mainstream things. You know what I mean? So that's the way I've gone with it, and that's the way I've adapted. You know what I mean? I've adapted modern technology with like trying to use what the ancients used for observations. You know what I mean? I'm trying to mix and match two things to find out these things, because without it, I wouldn't have been able to put the presentation together, and I wouldn't have been able to show people that, look, you know what, the observations I'm making, they are quite accurate. You know what I mean? You try aiming a compass at the moon, at a normal compass. Yeah. It has to be on a level surface for starters. Yeah. So I could only either put it on a table in front of me and move it round, or would it be easy just to download an app, which we know is pretty accurate because I've actually tested the app with a compass. Yeah. So I know my compass, it matches up with the app I'm using, and I know the app I'm using matches up with what Mooncalc's using. So to me, I think it's a pretty good ground for building up observations. You may not agree, but I agree with it, and I'm sure there's other people out there who agree too.
Thanks,
Dave.
Dave.
What that picture you just put up there a little bit ago about the waning crescent, what's your theory on why we could see the rest of the moon? I know you overexposed it, or probably through time.
I don't think it's Earth light. That is for sure. They call it Earth light.
But yeah. How could it be? You're on the dark side of the.
Exactly. So I don't know how it works really. I mean, what I do, I just turn the exposure up, and it lights it up for some reason. Why does it light it up? I don't know, because with the naked eye, you can see the disc faintly, but you can't actually see the bright side of it. Like I say, it could be a camera thing, or I'm not sure. I really could. Like I say, it's difficult to say. But it looks cool.
Yeah. I'm thinking maybe it's always lit. It's just that the light isn't bright enough for our human eyes to pick it up.
Possibly. Yeah. Possibly. Like I say, with the camera, it's just strange how the camera can pick it up. But like I say, you can see it with the naked eye, but you can't see it as obviously as good as you can when you use the camera. Because what I'm doing with the camera, you see, I'm making the actual lit side of the moon be a lot brighter than it actually is, and it's actually affecting all the actual dark side of the moon, which is interesting.
Now, have you been able to duplicate that at different phases, like half moon?
You can do it. It's difficult at half moon, but you can do it just before a half moon. I've done it just before half moon. I think I could probably dig some pictures out now where I've done it. Like, it's a lot easier on a crescent moon though, for some reason. But it is possible up just before, I'd say, first quarter, or just after last quarter.
I like that picture too that you did where the moon projected that overexposure.
That's interesting, that, because that was the perfect shot for me to try and explain about the moon being a projection, because people say, what do you mean a holographic projection? I'm not talking holographic projection. I'm talking of a natural projection, like that camera caused when I took a shot and the moon was overexposed, and the actual reflection on the actual lens created an image of the moon. I'm just saying to people, now think big. Now think of that light hitting that atmosphere, and that atmosphere creating that actual image. You know what I mean? So that's how I try to explain it in layman's terms, to try and let people understand that, yeah, I'm not saying that I don't know what the moon is beyond that point. Yeah, all I'm saying is that what we're observing in the sky is a light in the sky, and a projected light, and nothing more. Yes, it looks like a rock. Yes, it looks like a disc. It looks like it reflects. It looks like it emits. You know what I mean? It looks like it's everything all in one. And one thing I've always stuck to my guns with as well, in regards to how things work, I think something supernatural needs to take place for it all to work. I don't think it can work with just conventional science, physics, or geometry. I think something supernatural has to happen for everything to work, if that makes sense. Yeah.
And I haven't even gotten to this part in your presentation yet, but didn't you get into electromagnetic talk?
I did the research I needed to do the presentation. Yeah. And what I did, I found a book called Ether and Gravitation by a guy named William Hooper. Now, that book is one hell of a book. The first half of the book is all about electromagnetism, matter, ether. It's a really, really good book. And what I did, I just picked little sections out of the book. But the book is actually like he is actually a globularist, and obviously he does support gravity, but he does say in the book that ether is like the only true force in nature. He actually admits it in the book, but then later on he backpedals. So I used that book for my research. Yeah, and it's called Ether and Gravitation by William Hooper, and it is a really good book. If you download it on Google Books, you can actually click play loud, and it'll actually read it out to you loud as well. So it's definitely worth getting, just to look at the section on matter, static and ether, electromagnetism and ether, Kepler's law and ether. There's a section on Kepler's law and ether as well, which was good. So I highly recommend looking at that book. So like I say, I didn't touch on, I know that everything around us is electrical. I know that the sky is electrical, and where my hypothesis, where I'm saying that there's two poles, yeah, not one single pole vortex, I'm saying there's two single pole vortices, and I'm referring to celestial and not the terrestrial poles like you'd be required on a globe. So I'm just referring to there being two celestial poles, and it's pretty clear that when we point a camera north and you do a time lapse and you get the stars rotating in a counterclockwise motion. Now, if you go to the same point in Ushuaia and point your camera south, you'll get a very similar star trail, but in the opposite direction. Now, that works just like a magnetic field. Yeah, two magnetic fields work and they both turn away from each other. Basically, like the sky, I basically compared the sky to a giant magnet, where you've got a northern circuit and you've got a southern circuit. And as the moon gets southern declination and crosses the celestial equator, it will pick up on the ethereal currents in the opposing vortex and be circling the opposite direction, and vice versa. And it's just like a system where it passes from one vortex to the other. That's my theory. I'm not saying those are the facts, but from my observations and from my friend's observations in New Zealand, it appears that we've got two circuits in the sky.
Isn't it amazing what we amateurs are coming across in 3 years?
Yeah, like I say, it's, you know what I mean. I'm just going by my observations. I'm just building conclusions from my observations, because there's nothing else I can do. You know what I mean? If they're telling me I'm living on a single pole vortex and I'm not observing that, you know what I mean? When you're seeing looking at the sunrise times in places like southern Argentina, and the sun rises south of the observer, is visible for 18 hours a day, and sets south of the observer, that doesn't fit a single pole vortex model to me. It'd be impossible. You know what I mean?
Something else you said too earlier about somewhere in Europe, for the moon comes up less than 24 hours later, which doesn't that mean that more than 180 degrees of a ball would be lit up by the moon at the same time?
Well, yeah. If you go to time and date, and you go to the if you put in September 2018, what you'll do, you get the moon rising times. Now, the mean time of the moon, as we all know, is 24 hours 50 minutes. It rises every day. but during the equinox, we get what you call a lunar standstill, but I call it the lunar jump, because it's the Earth that stands still, not, you know what I mean, the Earth stood still. So basically, it's got to be the moon that's jumping. Now, the further south you go to the equator, the less of a jump it is. The further north you go, for me, it jumps. It rises 20 minutes later every day, between the 23rd and the 26th. That's why they call it the harvest moon, because the farmers used to use the extra moonlight, you know, the extra time in the moonlight to work. So because he could get the work done like 20 minutes earlier every day or whatever. But when you go extreme north to like Svalbard, it's rising less than 24 hours a day. You know what I mean? It's how that, I haven't really looked into it a lot yet, but when I saw the rising times, I was like, whoa, this is less than 24 hours. How is this possible? You know what I mean? But that's at like 78 degrees north in Svalbard in Norway, which is them little islands, which is just off Norway.
Can I say something on that bit there? I've said it before quite a few times. I went to work, and I was only at work about an hour and a half. And when I actually went to work, the moon was there. And when I came out, the moon wasn't there. And I had to drive 7 miles before I could see it again.
It's interesting. It depends on what part of it's, you know what I mean, what part of the actual
Well, I was thinking
cycle it was in.
if I had to drive that far, how could someone in London or Birmingham or somewhere else see it? If I had to drive 7 miles before I could see it, and it had gone in the valley, I mean, I think you'll agree. The moon and the sun, they go on tracks. They've got tracks up there. They stick to these tracks. On tracks.
Yeah, when you start looking at the sun is very, very stable compared to the moon. The moon is all over the show compared to the sun. Like if you look at the meridian passing times on the sun, yeah, they very rarely change. They just creep up, you know what I mean, a little bit throughout the year. But the moon, you know what I mean, you see massive degrees jumps. It sometimes jumps like 9 or 10 degrees in one day, whereas the sunlight just moves a little bit each day. But yet they work perfectly in harmony. You know what I mean? Yeah, you put them together and they work perfectly in harmony. But you wouldn't think with all the anomalies and all the changes in speed from the moon that it would actually work in harmony with the sun. That's why I think something supernatural needs to take place for everything to work, because it doesn't seem to fit physics or geometry or math.
At least what they've given us.
Yeah, at least what they've given us. And that's what I mean. We're only going by what we have ever been told. There could be something completely different up there. You know what I mean? I'm going to stick to ether, because when the Michelson-Morley experiment took place, they had a choice, yeah, to either demolish the ether or say the earth was stationary. Yeah. The latter one doesn't fit their agenda, so obviously they had to abolish the ether. I think the ether exists. In fact, I know it exists. Yeah. So I'm going to stick to that side of things, because that's where my research has led me to. You know what I mean? I haven't just chose to come to here. This is where my research has led me. Yeah. And the majority of people I know have done their research always end up at electromagnetism. Yeah. Or the electric universe. That's where that's where it leads us to. And I think that's where the answers are, because everything is electric when you think about it.
Hey, Dave, this is something totally different. About 2 or 3 cycles ago, in fact, the whole time I've been looking for a photo that I took, and I cannot find it. So I hope it's not lost. But anyway, the moon was about day 3 or 4 of its cycle, maybe 5. And
so still a waxing, like a crescent moon.
Yes. Yeah, it was a waxing crescent. I'd say about day 5. And it wasn't just on the right half. It was more right half, and then it would light up at the bottom past 6 o'clock to 7 or 8 o'clock. There was this little sliver that was lit around the bottom. I was wondering if you've ever observed that.
I think I've got some pictures of that somewhere, because I've actually took a picture close up of that. I've noticed it quite a few times. It actually, you think it's going to stop there, but it actually goes quite around the disc, doesn't it?
Yeah, yes, makes absolutely no sense in the heliocentric model. None.
No, I've definitely got some pictures of it somewhere, but I'm not sure if they're on the actual camera or on my computer. And I've got like about 500 pictures on my computer, and it take a while to go through them. But I will dig it out for you, because I've actually. In fact, let me just, while I've got this open here, let me just go to my page, because I think I might have a picture of it on my actual.
Yeah, that'd be awesome.
Page.
But that's another destroyer right there. Makes no sense how that could happen in their model.
Before you actually share, let me know, Dave, and I'll switch.
Yeah, I will do. I'm not going to share without it. I need to find it.
Can I say something? I'm not a cameraman like Dave or anything like that. But when I started to look into flat Earth, and because obviously I just have this, this room I'm sitting in, which I spend a lot of time in, I can see it all happening, because it's looking at the east. And I noticed that sometimes the sun goes like straight across. Sometimes it comes in almost like half a triangle, always going on a track, always on a track. The sun never goes over my house. It always goes next to my house. But the thing is, I noticed was that sometimes even the moon, they come in fast, goes out fast, comes in slow, goes out slow, comes in slow, goes out fast, comes in fast, goes out slow. I hope you got that. This is what this thing's doing. So sometimes it would come in really fast and be in this position, and then spend ages going over my house, and then off really quick. It changes every day. That's my observation out of my window, as I've greeted many a dawn and things like that here.
I've never even thought of looking at it like that. That's something interesting to take a look at.
If you start looking at it when, you know, in the mornings or whenever you see the moon, you'll suddenly say, hey, I can almost see the moon going across the sky with my naked eye, like it's going that fast. And other days you think, wow, it's still there. And it's just, you know, my observations like that. And the same with the sun.
I'm nearly there now. It just takes a little bit for the actual screen to load when I'm scrolling down quite far.
That's okay. Now I'm going to use you as a source, Dave. How about, have you ever taken a time lapse? I've been trying to find, for people on my channel, I did a video where the moon is right side up, and as the night goes on, it seems to rotate clockwise. And by the time the moon's setting, this is full moon when you can see it the whole night. I noticed this when I was living in Southwest Arizona last year, where it was a great open plain, and I could see from east to west, no obstacles.
Yep,
And
it's called field rotation. I can actually explain to you how field rotation works from the observer's perspective. I'm going to get the actual video, the actual meme up for you. It's like an educational meme I did for it. I'll show it you now.
Okay.
I'm going to sec. I say I'm on Patricia now.
Yeah, I'm still scrolling up to it. It's here it is. Got it.
I got so many comments from people saying I was a liar. That never happens.
No, it does rotate, but it's only due to the perspective. I'll explain to you in a minute.
Okay.
So right, I'm gonna share the screen now.
Yeah.
Yep. So share application window. Share.
Put the hangout down.
Hell or not. Oh well. So, can you see the picture on screen?
Yep, hang on. There you go.
This works same for the moon rotation as well. So if you, I don't know if you can see this, but for an analogy, basically imagine the moon fixed on your ceiling and you stand with your back against the wall. Yeah. And if you keep your eyes fixed on that moon and now you walk towards it, yeah, as you get towards that moon, you need to rotate, but you don't need to only rotate your head, you need to rotate your body in 180 degrees. Now the moon will have rotated 180 degrees from your perspective. Basically, it's because you're having to turn around to see the moon. Yeah, that's why the moon rotates, due to perspective. It doesn't actually rotate in the sky, it's just due to perspective. And it's called field rotation.
Which would be the same reason why someone in the south of the equator would see the moon upside down versus us.
And that's why I've done the picture. One's from the south, one's from the north. The one on the right from the northern hemisphere, and the one on the right left is from the southern hemisphere. Does that make sense now?
Yes, I just saw a video somewhere. And I see so many, and I just don't necessarily keep track of them. But this person was saying that as the moon moves, he was comparing the moon, showing the moon moving over the Earth, the magnetic fields of the Earth, and he had the magnetic fields colored blue or red, I guess north and south. And when the moon, anybody observing the moon over the northern or over the blue part would see the moon upright, and over the red would see it the other way. And he said people that are in between sometimes see the moon one way and sometimes the other, depending on the moon's exact path over those magnetic lines. I don't know if you'd seen that or not.
No, like I said, the only time I've observed the moon upside down is when I've actually done a moon sync with a guy called Robert Jackson, who was in Tasmania, Australia, nearly 12,000 miles away. Yeah. So, sorry, 11,000 miles away, where basically I shot the moon on the night when it was rising, and he shot it the next day as it was setting.
Oh, so, okay.
Yeah, I've actually got it on here somewhere, but I don't know where it is. There, what you can see on the screen there. I don't know if you can see them two images.
Yeah.
Well, that's an image I took myself with a 400-pound camera, and that's a one from NASA with their 904 million pound camera. So I was just comparing the shots, really. You know what I mean? I thought mine actually looked better than theirs, actually. So it just, but yeah, like I say, that moon sync I did with the guy in Tasmania, Australia. I'm not sure where it is on here, but I'll have to dig it out. It's actually there. That's the one there. So it's not the brilliantest picture he took, but he had a lot of cloud up there. So that was my moon at 7 on the 17th of 11th at 1955. That's where I took a reading. That's the distance. And there was his moon. It's not a brilliant moon, I know. Yeah, because obviously the picture's been destroyed a bit by Facebook as well. But he basically took it the next day. And what I did as well, to back up my claim as well, if on the actual write up to the thing, we was actually talking about doing this moon sync. I actually included that with it. So see the events unfold. So if you click on that, then you'll see where I'm planning to do a moon sync with my friend Robert Jackson in 80 minutes. Clear skies at present, blah blah blah, and it actually unfolds here, so you can actually see the event unfold. There was his skies. Look, you can see he had a lot of high altitude clouds. Yeah.
Mm-hmm.
So you can actually watch it, and there's one of his shots. And then
Dave, can we see the two moons side by side again, please?
It's not a brilliant picture of the actual moon,
I know.
But that's his moon there, and mine is the opposite way around, rotated 180 degrees.
You can see that the darkest part of the seas, upper right there.
It's difficult to see, like, but.
Oh, Dave dropped off.
Oh no, he's pressed something wrong on his computer.
Yeah, no doubt. Yeah. I had a little clip, not a clip, a picture that I showed yesterday, Karen, with the moon phases. And it's almost like, you know, there's 4 phases to the moon, and then you've got the 4 opposite phases. So you get like a mirror aspect of what you're seeing. And when you see a quarter of a moon, you get 3/4 the other side, don't you? It's, yeah, food for thought anyway, definitely.
By the way, I've got a video that shows 2 red stars, and the moon passes over and hides them, and then as soon as it comes out on the other side, which it's a half moon, basically, they come back. You can see it right through the dark part.
Sorry about that. I closed the complete window down, didn't I, with both the tabs open.
Welcome back, Dave.
I'm just going to go and get a little drink, yes. I'm getting a bit dry here, so I'll be back in 5 minutes. Okay.
Alrighty.
Oh, right. We just lost Astral as well then. So it's what do you call it? Bumper cars on the hangout today. As long as you're all right, Rich.
Yeah, you want to let me share my screen?
Yeah, sure. You know how to do it. Like Dave.
Yeah. And we're safe, by the way.
Cool.
I think I'm screen sharing now.
Yeah, it's just me. There's a picture of me, Rich.
Now, I don't know if you're going to be able to see this. Let me make it larger. This is a cool video. In fact, anyway, you see these stars?
Yeah.
2 little red stars. Now, I'm going to play this video. And you can see the moon is getting ready to eclipse the stars. Let me jump it a little bit. Just want you to see the moon, how it eclipses them. There goes one. And here's the other one down here, if you can still make it out. Okay, now they're behind the moon. Now let's move it forward a little bit. Remember, one was here, one was here. Watch what happens. This is a brilliant video. In fact, it's probably the best one I've seen. So you see it's a half moon. There's the first one coming out. In fact, you could see it as it comes through one of the seas here, the dark parts. So there's one. Now here comes the other one. Isn't that amazing?
That was exactly what I was talking about earlier, Rich.
Yeah, there's way too much evidence now
see
to
something
show.
Through them. You can see something through them.
Absolutely. There it is right there. Same 2 stars.
You don't think that what it is that you're being told that is behind the moon when it isn't, it's actually in front of the moon?
It
Well,
might be in
we
front.
don't
Yeah.
know.
And that's why
Yeah,
you
who
see
knows?
that. You see it like that because it's actually in front of the black part of the moon, which we I know we're not seeing there, but the star isn't behind, the star's in front, and then
That's
that
another.
would work.
Yeah, I never thought of it. That's another possibility.
So
in
when
which
you see
case,
stars like that, all
sorry.
the stars are in front. And I also on Sun and Moon have put this night video, a high altitude balloon one, and it goes up to about 17 miles up, and you can see the stars below the camera.
Can I just say something? The closest star we have to us isn't it the moon?
I'm just saying the stars are only miles away. Not all of them. Some of them are higher, but the stars start only miles away.
Yeah,
So,
but apparently, according to mainstream science, all stars are light years away. Nothing is close to us. Nothing. So how is it possible we can see a star this side of the moon? If you understand what I'm saying, from
yeah,
between
but that's
the
it, isn't
Earth,
it? It's like we
impossible
still know
between the
nothing.
Earth.
We're still no. I'm sorry, Dave knows a lot, but I mean, generally, we just like there's so many questions.
Yeah, I'm back. I've got a good question for you here. Right, we all know that water's flat over large bodies. Now, what tool do we use to actually measure that against? We all use that Earth calculator, don't we? That is actually mainstream, that calculator. So what a lot of flat earthers are doing, yeah, they're using mainstream tools to prove the Earth is flat. I'm doing exactly the same thing, because when you've got people like Ranty measuring long distance over large bodies of water to prove it's flat, is then comparing it with the Earth calculator to prove it's flat. So you know what I mean? So I'd like to hear your feedback on that, Astral.
Dave, we're on the same side, brother.
Yeah, I understand we are, but I'm just giving you an example where flat earthers are using mainstream tools, yeah, to measure large bodies of water to prove that there's no measurable curvature.
Yeah.
My good friend Jennifer measured the Toronto skyline from Fort Niagara, 30 miles across, and she used the Earth calculator, the Metabunk calculator, to debunk the heliocentric globe model with it. So we have to use these tools at times. And like I said before, the only reason why I use mainstream tools is for simple to make sure that when I'm aiming my app at the moon, that it is where they say it is. Because imagine if I pointed it at the moon and it was 180 degrees south, then I went on to time and date and they said no, it's 270 degrees west, then there'd be questions being asked, wouldn't they? So we have to rely on certain mainstream tools.
Exactly. We have our science, we have these formulas. These are our baseline. This is what we're going from. This is what we have to use as our, well, we don't have to use, but we're going from it because that's what science has used as their baseline. Now, if we use the same baseline, we're getting different results, then there's something wrong. How can our results be different than their results? If you understand what I'm saying.
Yeah, and that's exactly what I'm getting.
We're looking for the truth. We're finding the truth. And before, I didn't mean to insult you, Dave, believe me.
No, you didn't insult me, but I'm just giving you an example where you do need to use mainstream tools if you want to get any further. Yeah, because I don't know how to use an astrolabe either.
Sorry,
so,
Dave, I beg to disagree. We are programmed to believe we have to use these mainstream tools, but no, we don't, because we can use our own minds. We've got our own, reasoning. We can think, the way that we're thinking.
Astral, you're saying that to someone that's done his own research.
Yeah,
so
but Karen,
he knows.
I'm promoting.
He's doing that.
Karen, I'm not slagging Dave. I'm not slagging you down, brother. I'm promoting you. You're cleverer than that. You're smarter than that. We're all smarter than that. We don't need all these flipping formulas from thousands of years ago to say this is how far that is. Okay, we know we can rely on a lot of mathematics, but we can't rely on all mathematics. What I'm saying is this. What you have, Dave, is special. You can see, you've filmed it, you've photographed it, you've taken distance, you've taken time, day, azimuth, meridian. You've got all of these readings. There's people all over the plane of the Earth. they've got the same or similar readings, results, and we're finding differences than what mainstream science has told us we should find. We're finding differences, anomalies.
Well, isn't
Not the
Dave
same.
doing that? Isn't that what Dave's done?
Yeah, but that's what yeah, okay. I give up. I'm on the same page as y'all. I'm telling you, we're all together in this. We're trying to find out what's right and what's wrong.
Yeah, I'm not saying you're wrong. All I'm saying is,
babbling
yeah,
a bit, that's all.
I
I'm babbling. That's all. I'm babbling.
I've got a full-time job, yeah, and it's a lot more convenient for me to just check my readings with mainstream than me to get to buy an Astral-Lema and learn how to use it, because without these tools on mainstream, I'd never be able to put the presentation together, and I wouldn't be able to have something to verify my results, because like I say, I need to make sure that what I'm aiming at is where it's supposed to be.
Basically, you know? Dave Marsh, what I'm saying to you is, trust yourself. You're lacking trust in yourself. You're lacking your own judgment.
No, I trust my readings. It just I want to make sure that they're all accurate compared to mainstream, because the first thing a globularis will say to me is,
yeah, that's it.
Well,
he's got to do it the globe way to show them that
I haven't got to do it the globe way, but the first thing they'll ask is, well, why you compare it against the working model? You know what I mean?
Yeah. Okay. Yeah. But what I'm saying is, the things that you're seeing, that I'm seeing, that I'm hearing you say, you've taken good readings, you've taken good photographs, films, and you've documented everything. You've done an amazing job. What I'm saying is, trust yourself. Don't have any doubts, because what I see, and I believe what I'm seeing. If you understand what I'm saying, I know you're right.
What I wanted to show you, Karen, as well, while I'm here, I just wanted to show you that the full moon.
Okay, we're back on Patricia again.
Yeah, let me just get the full moon up on the 20. I think it's the 24th, 25th. Let's see.
Rich, right. how do you present without the hangout thing there? Then I've tried to delete it; it doesn't happen. Oh, didn't hear. Sorry.
How do I present without the hangout?
Yeah, linking it, which should be for everybody on the hangout. It should.
Oh, I just go up to the browser bar, where you type anything in, any web address, because that's where I just delete it. I hit Control X. Just totally deleted editor.
Right, oh, wow. Can you put the screen on me now, Karen, just so I can show you this demonstration?
There you go, it's on you.
Right, if you look here now, can you just see this full moon down here at 99.8%?
Mm-hmm.
Can you see that there? Yeah. So if I move the bar across the hours, what you'll see, it'll go to 99% at the time is like 1:08 there. So if you look now, it's gone to 99.8. So within that few hours scale there, we've already gone from 99. Yeah, it doesn't actually go to 100%. There is a point at 100%, but that'll give you an example. Look, just a little small time it's traveled. Yeah, so it's gone from 99 to 100 back to 99.8. Yeah, now if I go to 2019, and you go to January the 21st, or is it the 31st? It's gone to 2009, that's why. Yeah, I'll take then. Right, that's it. Now we want to go to the 21st, I believe. Yep, and as you'll see there, so can you see the moon at 100% there? At the time, it's just nearly 1 o'clock. Now watch this. 100%. Sorry, 100%. 100%. 100%. Slowly. Right. As you can see, from just before 1 o'clock, 12:58, the moon is at 100%. Yeah. Now what I'm going to do, I'm going to drag the bar across. Yeah. So 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock. It's still at 100%. Yeah. And we've got 7 hours. Yeah. So We've gone right through till 9:29, which is 8.5 hours at 100% full moon. How does that work on the heliocentric model? That is impossible.
And is that the day of the eclipse also?
That's on the day of the eclipse.
Wow.
But it's interesting that it only stays at like, I mean, if you look at the other percentages now, yeah, 99, 98. Yeah, it's dropped 3%, looking less that time already. See it?
You know, the last lunar eclipse we had here, the eclipse started and ended. Well, maybe not ended, but it started and went through almost all of it. I'd say at least 75% of it. And the moon was not yet 100%. That's impossible too.
Yeah, well, like I say, that is, and I've noticed it a few times, and when I looked at on this one, like, and I see it's like for nearly 9 hours to have a full 100% moon for 9 hours. It just doesn't fit very well the heliocentric model. That doesn't. It's interesting anyway.
So what does it mean?
Well, we've got to do a little bit more research into that. Try and find out why it stays at 100% for so long, and also on the equinox, why the moon is making massive leaps north and rising less than 20 minutes a day in the UK. But if you go like to extreme north, like Svalbard, at 78 degrees, it's rising in less than 24 hours. So,
Dave, there was 2 terms you used earlier, and I can't remember exactly what it was. One of them was lunar jump, I think, and the other one was something
lunar standstill.
Lunar standstill, that's it.
Yeah.
What does that mean?
Well, apparently, I mean, I've only just looked into this. I've seen something about it before, but I never really clicked on it. So what they're saying is, on a major lunar standstill, it will appear that I don't know if it appears that the actual moon actually stands still itself, or it looks like the Earth standing still and the moon's making big jumps. I have to do more research on it. But what I did notice, like when I was searching for lunar standstills, that there is a minor standstill coming up on the 23rd, 24th, 25th. Now, if you look at Mooncalc on them dates, then yeah, the moon's not standing still at all. It's making huge jumps on them days. So that tells me it's more of a lunar jump than a lunar standstill. On a globe model, it will probably look like a lunar standstill, if you know what I mean, because it'll probably look like the globe has stopped spinning because the moon is actually moving at the same time as the Earth or something, or whatever theory they've got for that. But what I will say is something very, very strange is happening on the 23rd, 24th, 25th. Even though it's a regular occurrence on the autumn equinox, it coincides with the full moon. So I don't know if anything's going to happen, but I'm going to be out there with a camera to find out from the 24th, 25th to find out if anything does happen, because I ain't got it open no more. But I could have just showed you sun calc and moon calc, how both the moon and the actual Earth are supposed to be aligned with the ecliptic on between the 24th and the 25th. Yeah, which to me, I know
3 days late.
Yeah, which is 3 days late for starters. Yeah, I should have really showed you that, really, just to get you to see that. I'll get time and date up and I'll show it you.
Alrighty.
Yeah, I have to say that in the summer with the sun, I thought the sun almost stood still for a while. Quite a few times in this summer. It was so high, and it was a bit like, because, you know, I mean, even you, Rich, all of us, most of us, we go up, we're looking at the sun and the moon a lot more and where they are and what they're doing. And I remember telling Astral, like, it's still there in the same place.
I've just had a mind melt. What am I looking for again?
Oh.
Can you remember what I was looking for? I'm going to show you something, weren't I?
Obviously, they turn up the Wi-Fi and we're all getting fried and we're having brain fart. It happens all the time, Dave. It happens all the time. It's happening to everybody, man. I'm telling you.
Yeah, I've got severe ringing in my right ear as well. So
my left ear, I've had it for years, but we're forgetting so many things. I was talking to Karen. Hey, Karen, what about what was I saying now? You know, it's like that, and we do it all the time.
Yeah, so I've got the moon rises here up for September. I'm just going to share the screen so I can just give you an idea.
Hang on. Right, you can do it now.
Yep, so I just... Right, can you see the screen now?
Yeah.
Maybe I can make it a little bit bigger. Well, if you look here from the 23rd, when the moon rises at 1846, look what time it rises the next day. 1908. Yeah, which obviously is literally an hour and 20 minutes later. Same again, look.
And the hour and 20 minutes. So that's, and your longest observations were generally 58 minutes or something like that, if I remember.
Yeah, that's strange, because what is strange is the meridian passing time doesn't change. The meridian passing times are exactly the same. This is like really head-wrecking stuff. Yeah, if you look at the meridian passing, it doesn't match the rise times.
Sorry, Dave. Wow. Did you say an hour and a half there? Where are we? I'm trying to.
Well, if you look on the full moon,
20,
yeah,
the 25th.
Yep. Say 1929. Yeah.
Yeah.
If you look there at 1950, which is 21 minutes.
10 to 8.
Yeah. There's only 21 minutes between rising times. There should be like a mean time of 50 minutes, which is normally between 40 and on the hour kind of thing, 25 hours. But interesting, these meridian passing times don't match up with these rise times at all. Look, these are all consistent, these meridian passing times, you see. If you look at there, look, 138 and 224 is way off that.
Oh, Dave, you kind of give me an idea here. I like these degrees, I really do. And especially time, date, degrees, because we can make pictures out of those things. So I'm going to take a screenshot right now.
Hey, Dave, why does it say on the 23rd, which is only 2 days before the full moon, that the moon does not pass the meridian on that day?
Because it rises at 11:24 and it doesn't, and it's set, and obviously it passes the meridian at 11:24, but the next time it passes it, it's past the hour, you see, because the moon takes over an hour to get to occupy the same spot. It's not on the same day, you see, it's on the following day.
Oh, okay.
Yeah. You get it?
Yeah, I got it. Thank you.
Yeah. So that's why it does that. That got me scratching my head at one time, that actually. But I wanted to show you something else on here as well about. Maybe I can show you on MoonCalc. So if we go to 2018.
You know, even the path of the moon, like on, I think, what's it called, SunCalc too, when it does the sun, these don't make any sense. Look at that circle it makes for you locally.
Yeah, it's mad, isn't it? And not only that, they're showing you a geocentric model, look, because the Earth stands still, and guess what? The moon's going round. Yeah.
Yep.
That's also something, before you get into anything, it's also something that pisses me off all the time, because everything is based on the wrong model. I'm going after geocentric and it's all heliocentric. Everything you look at is basically heliocentric. All of these calculations, they're all fucked up, man. Sorry. They're all wrong in a sense, because they're not based off a geocentric Earth.
Interestingly, when you get to these extreme places north, yeah, you'll notice that the moon's circumpolar, so it's visible for 24/7. Yeah, all day.
Now, is that also true in the summer?
Yeah, it doesn't matter what, the moon doesn't follow the same path as the sun. Yeah, so for 9 days, the moon will circumpolar on the really higher latitudes. Yeah, but you know, if you go 2 weeks, if you go if I drop it, say 2 weeks, it's not visible. Yeah.
Now, do me a favor, if you don't mind, find something in the summer where it does the same thing, because this is another blowout of the model.
Ready? So if I go to July 21st, well, I can't go to July 21st, but yep. So I'm in summer. Yep. There it is, circumpolar.
Oh, that's impossible. It can't happen both ways because, you know, they say the reason why you can see the sun up north in the summer is because you're so
Now watch
far
this.
north
Boom,
because the
not
Earth
visible.
is tilted, but that moon can't do that twice.
And there you go. It's 2 weeks later. It's not visible for 9 days.
Dave, you said something earlier, right? And it brought something to my mind. Anybody in the Southern Hemisphere that's listening, we ought to have people in the Southern Hemisphere, January, February to December, giving us a reading where the sun is rising, where the sun is setting, where they're seeing it from a southern point of view, right? And then we should also have people in the Northern Hemisphere doing the same thing, where the sun is rising, where the sun is setting, January, February to December, because we're all looking at the sun from the same direction, where it's rising, where it's setting, but we have two hemispheres, northern, southern, and I'm pretty sure if we did this, we'd find a lot of interesting things out.
What I will show you is very, very interesting here, because anybody who supports a single pole vortex model might not like this very much. But if you go to Ushuaia and you go to their summer solstice on December 21st, what you'll see is that the sun rises south of the observer. It's visible for 18 hours a day, and it sets south of the observer. Now, how they'll explain that on the single pole vortex model is beyond me, but they could have a good try, but I don't think they'll get very far with it. Yeah. You can also take into account the 13.5 degrees magnetic declination, which they don't include in this app, which would probably take it to about there, which would make no difference whatsoever. So as you can see, yeah, it looks like it's on the southern circuit. Yeah. In the summertime, our summertime, June 21st, what you'll see, you're only seeing a small arch of it, because when it's on that northern circuit, you're only getting to see that small arc as it gets to its furthest southern point from the north. Does that make sense?
Yes.
So as I see it, the sky is broken into two circuits, the northern circuit and the southern circuit. The moon will be on the northern circuit for 9 days. As it gets beyond the equator, it will pick up on them currents in the southern one, and it'll be turning in the southern circuit, but it won't be visible in the north then. That tells me it's passing from one vortex field to the next, you know what I mean? And it's the same with the sun, whereas the sun only crosses the equator twice a year, the moon crosses it 26 times a year.
What would you say then if I was to propose that the the moon is hovering either a little bit above, a little bit below, a little bit above, like the equator? Now it's going up, of course we know it's going up to the Tropic of Capricorn, Cancer, down to the Tropic of Capricorn, up to the Tropic of Cancer, down to the Tropic of Capricorn. It's making a little wave, isn't it?
Well, I call it the Luna-Lema because it's like a figure of 8 in my mind. Yeah, because it rotates one way in the northern hemisphere, then when it picks up them currents, it will rotate in the opposite direction in the southern. So it'll go that direction on the currents, it picks opposite direction and goes in the opposite way. I think I showed it with the Luna-Lema when it passes from one field to the next kind of thing, the one circuit to the next. That's my theory anyway, like I say, and that's just built on the back of my observations.
Does anybody on the panel know what the geocentrist view is of how far away the stars are?
Well, Ptolemy said they were fixed, so I would say I wouldn't know in a distance. All they ever say is that the stars are fixed. That's the problem with astronomy. See, from the very first moment of astronomy, they based everything on the stars being fixed. So everything from that day onward has been a blunder, kind of thing. You know what I mean?
I know there are people that pertain to know how far the closest stars to us are. I think Crow 777 knows the closest star is like, yeah, however many light years away it is, but it's a distance away anyway.
Well, a close one's supposed to be something like 40 light years away, which is like something like, is it 250 trillion miles away or something daft like that? It's ridiculous. The numbers they give you in astronomy are just absolutely ridiculous.
Yeah, but the thing is this, Dave, right? When we fully understand 1 light year, or even a half a light year, or even a quarter of a light year,
I don't.
it's absolutely immense. No, but if anyone's interested, look up a light year, how long a light year actually takes, you know, and you'll be very, very surprised.
I thought it was 9 billion miles or something, is it? Is it 9 billion miles or something like that? I can't remember off the back of my head.
No,
something we could never imagine.
I've not, you know what, I cannot quote anything like that because it's like, it's one of those ridiculous numbers, and it's one of those numbers that it's nonsensical that you don't even need to remember it because it doesn't make sense. It's just, you might as well just say 3 or something, you know, because that would just be as good.
The reason why I brought that up is I'm talking about the people that are into some people have been into the flat earth movement before, and they've moved to geocentric, where they believe the earth is round and everything moves around us. But what I can't find out is, at least I haven't so far, how far away they think the stars are, fixed or not. What's the nearest star? Or are they all the same distance away, whatever? Because they got a big problem. And if the problem is, let's just assume they're all equidistant away from the earth. So here's the earth. They're rotating once in 24 hours, and they come back, you know, to the exact same spot, you know, except for 4 minutes every night. Well, if they're, let's just say, 1 billion miles away, 1 billion, or even 1 million miles away.
Should be parallax in it. It should be.
In 24 hours to go all that distance, it's going much faster than the speed of light to get back to the exact same spot in 24 hours. You follow what I'm saying?
Yeah. Mm.
So to me, that's the biggest weakness for that type of thinking, unless they say the stars are very close.
Well, have you seen the recent videos I've been shooting where I actually shoot the moon and Jupiter in the same focal range? Yeah. What I do.
That's on my list.
Yeah. Well, basically, it's only a short video, probably about 4 minutes long, where I prove that the moon, not set at infinity on the camera, manually focused, and what I do. Luckily, Jupiter was in the close vicinity, and I literally just drag the camera down, and what you'll see that Jupiter's in the exact same focal range with the actual moons, Jupiter's moons as well. You know what I mean? I did that with Jupiter. I've done it with Mars. I've done it with Sirius, and I've also done it with Saturn rings as well. And they're all in the exact same focal range. And what I did then, I did another video proving that I wasn't in infinity mode, to prove to people that the camera is not set in infinity mode. It's actually manually focused quite a bit away from the actual infinity sign or the actual infinity mode on the camera, to prove that the moon and the stars are all at the same focal point, exactly the same focal point. You do not have to refocus. If you want to get Jupiter's moons, or you want to get Saturn's rings, get a good lock on the moon and try and pick them up in the same focal range, and they'll be in perfect focus.
I have said, though, as well, just say, Rich, that I did send you the video. I mirrored it. It's this high-altitude blue going up. They get up to about 17 miles up. And you can see some of the stars are below the camera. And as it's panning around, it's like Star Trek. I mean, how could that happen with the balloon? It's not going that fast up. So how could all the stars be moving in front like it's in Star Trek? That's because they're right in front of the camera. And some of these stars are below the camera. You can see it.
Yeah, it's a good point.
It's one of the only nighttime balloon flights up with the moon out.
Yeah, it's
so
the Perseids. It's the one from Spain where it shots the Perseids meteor shower into it. It's like a brownie color, isn't it? You can see the moon in the background as well. Actually, on that one, it's quite good because it's interesting to watch that video. I think they tried to pull that video. You know, it's quite difficult to get hold of now. You try and look for that Perseids video. It's difficult to get hold of.
Rich, I'll resend it to you. What you have to do is you have to sit more or less in a dark room because you're looking at the nighttime with some little dots in it. So basically, you need a dark room and even just slow the footage down. And I did put the link to the actual original on it for us to go, because you know when you copy it, you just lose a tiny bit of clarity that person had. But I was just like, wow, I can see the stars below the camera. So about what, 15 miles up?
Yeah, it's a great video. That it is the one shot in Spain over the. I don't know where it's shot. Somewhere in Spain. Somewhere. But anyway, they catch the Perseids meteor shower. It's in August time. I actually recorded the Perseids meteor shower. I got one shooting star, so I didn't do too bad.
The one that I've got's got music on it.
Yeah, I've seen it. Yeah, it's a good video. Yeah, the one with the airplane's quite good as well.
That's another possibility.
We need more of them to go up at night.
Yeah, so like I say, in regards to all my research, what I did for the first year, I just did it all by memory, and everything I learned, I just kept in my head. But as of now, I've built a bit of a platform on my page on Facebook where I find out little things. I just put it on there. But if I've got anything quite major, what I found out, I'll stick it in my presentation, or I'll add it to something like that. And like I say, I've just recorded the moon at apogee, at the actual point of apogee, at my zenith, measured it and recorded it past my screen, and I will repeating that experiment when I've got a decent sized moon that I can record, because I'm using that measuring tool. I can't remember what it's called now. I've got some measuring tool. I've got what to measure now. It's a good little app actually. It's called. Just click it on here a sec. Yeah, Bursoft image measurement it is. It's only a trial version, like, but it's good, like, because you can measure ellipses, you can measure the radius, you can measure the circumference of objects. Because we thought about doing some. Jenna Fredo got the idea about measuring the actual, doing star trails with the moon in the actual frame, and measuring the actual stream. You know what I mean? If you start the moon at zenith and you set it doing a 150-minute time lapse, then we can actually measure the actual distance to the moon if we do it at the same focal point, and realize just how far the moon's actually traveling from that point. Because obviously, if it's traveling quicker, then it'll cover more ground, won't it? So that's another experiment, and that's quite an interesting experiment to probably do on high latitudes or on southern latitudes, to see if, you know what I mean, if we're on a ball and the further north we get, and it's supposed to appear to rotate slower, isn't it, the further we get to the poles? Or is it the same for the star trails, or are we getting the same length star trails at 70 degrees as we're getting on the equator? You know what I mean? That'd be an interesting group of experiments to do.
What's the name of that again, Dave?
What's that? Sorry.
What's the name of that again?
Just doing star trails, high latitude.
No, the app or program, whatever you're speaking of.
That's just basically the camera I've got, the Nikon Coolpix B700. You just set it to Star Trail, 150-minute Star Trail. I mean, if you can afford the new Nikon, is it the D610A? Is it astronomer camera? It can do infinite Star Trails, until the battery runs out, which would be great for doing like very, very lengthy star trails. You know what I mean? If you want to do like a 4-hour star trail, it'd be absolutely brilliant. So, but that camera's like about £4,000 to buy.
Cool.
So it's a little bit out of my price range, I'm afraid.
I have a okay. It's not a stupid question. No question is stupid, but okay. We understand how cameras work. We understand that about how lenses work. We can buy lenses. We can see how a camera is built. Can we not make our own, flat Earth, telescopic camera, something that we can you understand what I'm saying? We're all clever people. We have abilities, and we have, you know, minds where we can all come together and say, you know what? I've been making lenses, and I've been doing glasses for, you know, 35 years. And I've been doing working with telescopes for 15 years, or I've been making binoculars for 25 years. My grandparents have been doing this for hundreds of years. We've got a factory. Maybe there's a possibility we can get together, figure out how could we make a perfect camera, a perfect telescope. We can do it. I mean, we're thinking about things that we're waiting for to come out. We can flipping invent these things ourselves, can't we? Am I babbling?
Well, one thing we need money. You know what I mean? you can't make these expensive precision instruments without funding. That's just the hard truth, isn't it? You know what I mean? And to make something as precision as a camera, imagine trying to put a Nikon Coolpix P1000 together.
David, please. There's a book you need to read. It's called What to Say When You Talk to Yourself, and it's about positive thinking. There is no there is no cannot, there is no can't. We have
people are always inventing things, though, aren't they? Unfortunately,
exactly,
just the wrong people have goes into the wrong hands.
No,
well, it's just research and development.
We've got the resources of people here. We have the minds of people here. Surely we can get together, figure something out. How can we get the best telescope? The best telescope. I'm not talking about a shit telescope. The best, something good that we can look at.
What, like the Vatican's?
Don't limit yourselves. Stop limiting yourselves.
They've got the best telescopes in the world.
yeah, for sure. Let's go down there. Let's kick in the doors. And,
they don't call it Lucifer for nothing.
You know, what's got to be rethought.
We can do this.
Okay, what we saying, Rich?
What's got to be rethought about telescopes is, and maybe the technology is good enough now where we can do this. And obviously, it is because of cameras, but the telescopes are made to basically put all the light in one little circular spot on the lens. And so this is why everything that we look at through a telescope, or pictures we see through a telescope, all bring everything into a perfect circle. Because that was the technology. The technology of telescopes, you know, ever since they started with the mirrors, really hasn't really changed so much. It's the idea of gathering as much light as you can into a focal point. But we can see now that with camera technology that Venus doesn't look like Venus. You know, a camera versus a telescope, they look totally different. In fact, the camera looks better.
Can I throw something in the mix as well? I don't know if Rich has seen him. I don't know if Dave has seen him. It's Enslaved by No Media. He's reckoning that a camera isn't quite representative of what we see with our eyes. It is long distance, but not short distance. What it is so something's in front of him, and he has to zoom the camera in to get it the same size as he sees it in reality. So you've already got to zoom in on the camera to get reality.
Yeah, it just started a bit of a negative zoom. I know what you're saying there. The camera, the Nikon Coolpix P900 and the B700 what I've got. If you just when you switch the camera on and it's just a set focal range, it looks like objects through the actual viewfinder are miles away. You know what I mean? So it's at a negative before you even start. And like you say, you have to zoom it in a little bit to get to the natural kind of a look at the camera. But yeah, you're right about that.
Because he's reckoning we're only half the size that they say we are, and things are not as far away, you know.
Well,
and it is a bit strange when he's saying that's a plane taking off 7 miles.
Well,
away,
think about
a town 13 miles away.
Think about this, Karen.
Wow.
Do you think I could really zoom in on Titan, one of Saturn's moons, with a 400-pound camera? Yeah, remember, I'm looking at it from between 750 and 1.2 billion miles away through the astral belt. You know what I mean?
Yeah.
Think about it, yeah? How the hell would you be able to zoom in on the moons, not the actual planet Saturn? I'm talking about its moons, Titan, or the other moons, what you can see with the camera, yeah? These are just impossible at the distance of 1.2 billion miles away, yeah? Just think about that distance.
I know, but if you look up a P900, you know what Comet said? that it can see infinity.
No, it's because it's got infinity mode on it. That's what that is. It means once you get to infinity mode, yeah, everything beyond that point will be in the like focus. Yeah,
one of the first things I saw when I came into Flat Earth was somebody was using, I don't know what camera, but they noticed that they were surprised actually, and it probably brought them to Flat Earth. They were filming a mountain range, something that was pretty far away, and the moon happened to be right near that mountain range, and they just barely moved the camera over, and they were shocked that the moon was just a little bit out of focus. They had to turn it a little bit, the focal range, but not much whatsoever.
Yeah, exactly. That's true.
Yeah, that's amazing. Well, without anything, we should not be able to see the detail. If you ask me, I don't care how big or small the moon is. At 230,000 miles, 230. Yeah, come on. We should see we shouldn't even see it.
Exactly. You imagine. I mean, even just thinking about it. Yeah, you probably won't even be able to see it at 2,000 miles away. You know what I mean?
Yeah.
Think about all that atmosphere you'd have to look through. Yeah, that moon probably sits in the sky. I don't know, it may be 50 miles away from the observer, but if you jump forward 50 miles, it would still be 50 miles away, because it gives you that, it's like an optical illusion, you know what I mean? It's that projection is always at a set distance from the observer, regardless of how close you get to it. And then you get to a point where you get to like, where it's perpendicular with you, then it'll be going the other side of you, you know what I mean? It's just like one interesting thing I did see when I took off to the plane to go to the conference last year. There was a daytime moon. And as the plane went up, I don't know if you've seen that NASA footage where it looks like the moon's a disc and it like rolls backwards. It looked like the moon actually rolled backwards like that as I took off. It was strange. It seemed to face me all the way up, you know what I mean? Regardless, as the plane climbed, that moon was always facing me as I was going up, and it literally tilted up with me. Like, it was dead strange. I wish I had the camera out to catch it, like whether the actual camera would have caught it or it was just like an optical illusion, you know what I mean? But it was a very, very strange looking moon out. It like just tilted towards me as I went higher and higher.
I've put one out about NASA, and as it goes across, you can see that it just rolls back. This thing it's not a planet, it's a disc. And it rolls back. And it's like, they're showing you. Yeah,
that's exactly what it did when I saw it when I took off in the plane, because I thought about that and I thought, wow, it does like roll back a little bit like a disc, because it's like that face always faces you regardless, you know what I mean? So, but that was a very, very interesting observation, and I just wish I'd have had my camera at that time. Hey, Rich, are you going to the conference this year?
The one in Colorado?
Yeah.
Yeah, I'm not speaking. I'm going to go there, but I am going to probably do a workshop. And probably will use some of your work if that's all right.
Well, interestingly, I'm going, and Robbie's asked me to do a workshop as well. So maybe we can
awesome.
Team up and do some work. Yeah, I'm getting there on the Tuesday.
Team up.
Yeah, so like I say, I did speak to Robbie about it at the convention, and he says, yeah, you come along and we'll do a workshop. So yeah, maybe we can team up and do something together.
That would be awesome.
Because I get there on the Tuesday. So
I think I'm going. We're driving up on Wednesday. It's a 12-hour drive, and we decided to do that instead of flying.
Cool.
Hey, can I add something in the mix that was just really weird the other day? I was talking to Bling Bling, and this San Diego came up, and she was going, "Well, that's hours away," and I'm thinking, yeah, it's hours away for me. I know that how long my trip to America. I went to San Francisco. It's like maybe 11 hours from the UK, and it's 7 hours from her. It's like, wow. She's almost got to go 3/4 of the journey, but she's already in America. We've got to go the whole journey.
Yeah, it's a long way. And Dave, it's going to be cold.
Yeah, I've heard. Yeah, so yeah, I've been looking at getting some decent clothing, like, because November in Colorado is supposed to be pretty cold, isn't it?
Yeah, and it's a mile high, so it's
Right.
You might want to take pictures of the moon there and compare the angular size. I've been thinking if we had two observers on the same day, one at the base of a mountain, one at the top, both taking observations of the moon to see if there's a difference in the angular or whatever the size of the moon.
That'd be good. Yeah.
But Colorado would probably be. I haven't been to Colorado personally. It's one of the states I've missed, but it's probably a great place to actually do something like that.
Yeah, like I said, they post have got some good clear skies out there as well, haven't they? Especially with it being like eye open that. So
Yeah,
You've already met each other anyway, haven't you?
yes, briefly.
Yep.
Yeah, last year. Yes, Rich did a good presentation. I enjoyed it.
Oh.
I'm surprised I was able to do it, actually. I was in a different place last year.
Yeah, you mentioned about it last year, and you know what I mean. It's same as me when I did the one in the convention. You know what I mean. I'd just obviously gone through a breakup. Yeah, I'd lost my home. I was living on my mother's settee. Yeah, I haven't done anything with my presentation for 3 months, and I've got to do a presentation in a month's time. So that was my scenario. So I had to basically kick myself up the backside and put myself into gear and basically force myself to put the presentation together, which was half complete when I got there, and I actually finished off of it in like 1 day. So
yeah, I mean, I can totally empathize with that. That was me last year.
yeah, but like I say, I managed to pull it off. But it's just a shame they didn't record it, and that's why I wanted to do it on Karen's channel to try and let people understand what, you know what I mean, the work I've been doing. It's just a shame that when I try to show certain individuals, big names in flat Earth, and I know they've seen the presentation. Because when I've messaged them through Skype or whatever, it comes up as seen, but I've had no comment back or nothing to say, yes, I've seen it, or thanks a lot, or anything like that. But they just don't seem to want to touch it. You know what I mean? Because some of the theories or claims I'm coming up with in my video doesn't fit their model or their agenda kind of thing. So I find that quite sad, because I'm not saying I'm right, but what I'm trying to say is at least have a look at it, you know what I mean, and see if there is anything in it. Like I've always said, that if I can just find one piece of that puzzle by concentrating on one aspect of flat Earth, namely the motions of the moon, then, you know what I mean, I'll be happy. And hopefully I can wake up some people on the way. But it's just a shame that some of these big channels haven't really, you know what I mean, apart from you, Richard, who's actually looked at it and said, yeah, you know what, you're onto something here, whereas other people just haven't said anything or commented or even, you know what I mean, acknowledged it.
Yeah, well, part of that probably is what you said. If it doesn't fit their model that they've latched onto, to me, even from the very beginning, it was too easy for the AE model to be just dropped in our lap, or out there for us to just pick up, if you know what I mean.
Exactly.
So I don't commit to a model, and maybe this is a cop out, but I know we do not see the sun and the moon directly. We see a projection both, and your work just points that out. And with that, when you see, a lot of people have done their work is taking calculations of the sun and moon and saying, okay, here's the model based on that. Well, that's all great if you have a local sun where you are and I have a different sun where I am because of two different locations, but I know we see a reflection of both. So we're seeing the same sun, essentially, because that reflection, I'm going to have to redo that video where I show that if you show a light going through a glass, no matter where you move, that light moves with you. So you can't base distances, the size of the map, any kind of things like that off of these two, in my opinion. Now, if we were seeing it directly, like the heliocentric model is, yes, that's or the idiot in Egypt that did the calculations at 400 BC or AD, whatever, Eratosthenes. That's, to me, that's irrelevant. If you realize that you can't see the sun and moon directly, and you can and I don't care what model you use the AE model or use the heliocentric model. When everybody looks due east within a degree or two, and someone pointed me out, I'll cover that in a second. But when they, on the equinox dates, they look due east and see the sunrise, look due west and see the sunset. Everywhere on the Earth, from the pole to pole, if you believe it's a globe, or the AE model, no matter where you are, that's impossible in both if you're seeing the sun directly. It just is.
That happens, though.
What's that?
I say if you look at the actual rise and set times, throughout the time and date and that, they do rise at 90 degrees, set at 270 on the, you know what I mean? It's quite common to see that it does actually rise at that time, say from my location and somewhere extreme in the south, like that.
Right.
Won't work on. That
Yeah,
wouldn't work on the circle model or the globe. You know what I mean?
right. That's right.
Yeah.
It blows both out.
This is where
if you say the sun is being seen directly.
Yeah, and this is what they do. They try to promote this direct, these objects being seen directly by saying they're pointing lasers at the moon. You know what I mean? When you're pointing a laser at the moon at an angle, for starters, yeah, that's impossible because they're telling us that when a moon rises, when the moon rises and the sun sets, we're not seeing the moon. We're seeing an apparent moon, yeah, because it's a refracted object we're seeing. Yet they're pointing a laser at a moon at an angle. So you can't have best of both worlds. Even if the moon was a solid object, the only way you would be able to point a laser at it, if it was a solid object, which it's not, is if it was perpendicular with the laser and the laser was shining straight up at it. Because that's the only time you get less refraction, when you're actually perpendicular with an object and not at an angle where you're going to get refraction, like when you put a straw in a cup and you see it bend.
And
Dave,
by the time,
sorry.
that's all right.
Dave, can I ask you a question about like the phases of the moon? What's your take on the phases of the moon? How does that happen? What is it that you perceive? Because I've got a million thoughts about how it occurs, and I still don't know. You know, I'm dreaming about it. Every time I look at the moon, I'm thinking like, what's going on?
Well, I haven't really got a theory for that, but what I've always stuck to is that yes, the moon is always facing the sun, regardless. As when you see these photographs and you see the moon at one angle and the sun at the other angle, this is where the field rotation comes into it. They're always facing each other really, but it's just rotated away from you due to perspective, yeah? So when you see the moon at one angle and the sun at one angle, say, well, look, they're not even matching. Yes, they are. It's rotated from your perspective, right?
So do you imagine then that, now I'm imagining the sunlight shining, and as the sun's shining, that sun is producing the moon, the opposite end of the scale, or the opposite side of where we're pointing at, if you understand what I'm saying. Imagine a pencil. You've got the rubber end on one end, you've got the lead on the opposite end. So you've got the sun on one side, the moon on the other.
Yeah,
and
one
them
thing
two are linked together, and they're, you know, either going up and down and, you know, revolving.
Yeah, the phases are related to the east-west motion, yeah, because what you'll find is, I've showed Karen this before, when the sun is high on the Tropic of Cancer, the full moon is always on the opposite southern latitude, yeah. It matches it within 5 degrees. So when the moon is high on the tropic, when the sun is high on the Tropic of Cancer, the moon is always low on the full moon is always low on the Tropic of Capricorn. And what happens is, as the sun gets declination, that full moon gets declination towards the equator, and they basically mimic each other, and they get to a point of the equator, then they cross over, then it's the other way. So in winter time, when you've got the sun low on the Tropic of Capricorn, you've got the full moon high on the Tropic of Cancer. That tells me that the full moon has nothing to do with the north-south shift, but only the east-west motion. Because you can have a full moon at different positions on the latitude. Does that make sense? It's probably best to show you the actual demonstration of that, because I did.
Yeah, I like to see pictures of things, because
yeah,
understanding from what you're saying, I can understand it, but I also love.
Are you going to show a picture,
not
Dave?
myself personally as well. People in the chat, if you can show it visually.
I've just had to dig out all. Let me just find out all the full moons then for this year, and then I'll give you a demonstration what I mean. You when you see it, you'll understand it better.
Okay, Rich, what were you going to say?
Oh, I was just, when he was talking about the laser hitting the moon, and these people think they're getting a laser back or whatever. By the time you would hit the moon and come back, it's only a few seconds. At that time, if you're moving 800 miles per hour, you've already moved way out of position to get that laser. By the time it would have come back, it's just it's so ridiculous that people actually believe you can shoot a laser at the moon and get a return from it.
Yeah, it wouldn't work because if we were revolving, would it?
No, in fact, if you go outside, jump up in the air, by the time you land, you should land several feet away because of the rotation of the Earth under you. And it takes longer than that for a laser to get to the moon and come back. It's just crazy. It's just, and the angles would be all wrong. It's just ridiculous that what people will believe.
Yeah, it's crazy what they've made us believe. Crazy.
Yeah, and we've never thought about it before.
Yeah. They
But
really got us into not thinking and asking.
Yeah, a thing for people to look up is something called troposcatter. TROPO scatter. Troposcatter, one word. It explains not only how they can do satellite dishes, but how you would get a return if you're shooting a laser up in the sky.
Right, that's good. Right, can I just go for a cigarette forward of this, because it's quite about a 10-15 minute lengthy thing, and I'm gasping for a cigarette.
No, you can't.
I've got all the full mums ready. Right.
Dave, so no problem, brother. Karen, can I just say, SKYFLYBRI wants to come on because he's got something he wants to ask Dave, if it's possible.
Rich, do you mind?
No, I don't mind.
Okay.
Well, I won't be here because I'm just going to go for a quick cigarette, but I'll be back.
All right, Dave.
That's what he tells us.
He sent me a picture, but I just was a bit concentrating on the hangout, so yeah, I didn't answer him.
Yeah. Anyway, Rich, let's hear a bit from you, brother.
What would you like to hear about?
Actually, Rich, I know why Dave's going to have a cigarette. What's happening with people4people.life?
Well, the bottom line, honest truth is with that, to make it work the way I want it to work, it's too expensive. That's one thing. And the other thing with the health issues, it's very difficult to get back to it. It's like it just keeps dropping lower and lower in priority as I have more and more things happen to me. So it's two things. Now, the site's still there. There's a couple things I've had to go from the like a pay part of the site, not people paying, but me paying for certain features and things like that. I've had to cut that back because I was running out of money every month just keeping the site with all these different things. What do they call premium parts of their apps or whatever. What I would really, really, really like is to have some app, hopefully open source will come out or is there, and I just don't know about it, where people can actually do this kind of hangout right now with one another on the site. That's what I would really like.
Yeah, so take it away from here and all the other places. Yeah.
Yeah. And eventually be able to upload. Now, someone, I think it was Chris UK, wanted to be able to upload some data there, maybe. I can't remember who it was. Somebody that in connection with you, Karen, wanted to know if I could, I think you sent me something on this, wanted to see if they could upload some data or something like that. Does that ring a bell?
I think so. A little while ago, though, now, yeah. But yeah.
Yeah. I haven't heard anything since. I was waiting to see if anybody contacted me. But I mean, that the site's not necessarily set up for that, but that's an easy fix. I could set that up.
So it's still there and it's still going, though, and you can still communicate on there.
Yeah, and I can still be contacted there. Like at the beginning of most of my videos, I'll put that on, or at the end, how I can be contacted. There's a contact form there. It's always been an issue with, it's still an issue with, I got to create an email to respond back. But you know what it is, if I give out my email address, what'll happen is it'll just get flooded in no time by the trolls. So that's just little, but I do have a contact form there. It's peopleforpeople.life/Rich. In fact, I was talking to somebody in the chat as we were talking. He wanted to send me some. I wanted him to contact me anyway because he said he was a person who could modify and has modified cameras for the infrared.
Oh, cool.
So, yeah.
It's all about coming together somehow, isn't it? And helping each other. So that's good.
Yeah, we can combine forces. I mean, it's amazing to me. You know, Flat Earth has really only been mainstream for 3 years. And how far we've come is astonishing. Really is. there's some things that I don't like about the movement right now. There's what I call the political wing, is where one person fights another about their model or personalities or whatever. There's the debate side where all they want to do is fight with one another. So I guess that's going to happen with anything that grows as fast as this is. You're going to get all kind of different things. I'd rather just sort of stick with more of the science and observations and combining talents type of thing.
Yeah. No messing about and being silly, because some of them are just attacking people all the time, and it's just horrible.
Yeah. Well, you know, there was an interesting comment I got from a troll the other day. He said that when I did a QAnon video, and they said, I've run out of flat earth things, so that's why I'm doing QAnon. It's like, you have no clue that we're just barely scratching the top surface of this. And that's how I believe. I think we're just barely etching in, and we've had so much to discover and so much to explore.
I think you're correct in that assumption there, Rich. We're barely scratching the surface. This is a new phenomenon. Yeah, new. It's not new, but we're a new group of people anyway. Let's put it like that. And getting together, we're testing science as a whole, and science as a whole will not come to the table and say, you know what, you're full of shit. They will not dare.
Well, we did have
yeah, okay,
we did have Robin
Rich,
on the other day, didn't we?
Yeah, Rich, you had a debate once with that guy. What was he called?
Crow. Yeah.
Yeah. Is he going to come back again?
I don't know. He's doing some stuff now with the Luna-Lema, and he's trying to make it work on the globe model. And I'm following that. That's pretty interesting stuff. You know, he's somebody on the other side who actually does the work instead of just says, you're an idiot, you don't have an education, you don't know what you're talking about. So I respect that greatly. Yeah,
but I think most of us began, like, when we saw, you know, flat earth, what? You know, that's how I interpreted it anyway. I looked at it, I thought, what, this is ridiculous. But I had to look into it to debunk it. And yeah, obviously, here I am, flat.
Well, you know, what was interesting is, I mean, it's just going to take us peeling away our pre-programmed, since birth, mindset. I mean, think about just recently, it took 3 years for somebody to think of using infrared to see further with cameras, to get rid of the haze and stuff like that, which is brilliant. I mean, it's like, why didn't we think of this before? It's like, duh. You know, take out some of the visible, you know, where the moisture and things like that are in the visible light. Infrared gets rid of that, so you can see much farther and clearer, putting an infrared filter on. I mean, I would have never thought of it, but somebody obviously did. And now look at all the distances are jumping where we can see much further.
Yeah, it's good. I'm very artistic, and whenever I do like art, you know, I always like do opposites, comparisons. You know, you do like, you know, black, white, yellow, red, green. You know, you do everything. You try it in all different ways. It's like a big kind of a soup in a sense. I think flat Earth ought to be, in a sense, a little bit like that. That we try everything. You try all sorts of combinations, you know, because suddenly you'll get a combination and that just meshes together beautifully, and it brings a whole new, you know, when you mix two colors together, you get a whole new color. When you mix four colors together, you get a whole new color, you know. Well, okay, maybe not, but do you understand what I'm saying? If you mix certain things together, you get different aspects, and it's the whole aspect with flat Earth. When we get different people from different, like Dave, he's photographing the moon, and he's got all that study and everything, and you know, other people that are doing other things. Stan Smith, for example, he's doing also a similar thing, but not quite the same. Although it is, when those Dave Marsh, Stan Smith get together, something magical could happen, will happen, should happen, ought to happen. You know, because yeah, that's just the way that things happen, isn't it? It's like a progression.
Yeah. Well, here's another one too. I recently showed a guy who went across a lake, and I can't remember where it was, but this whole idea, stupid idea of refraction, where things always lift in the distance, just to the height you need for the camera to see it, to disprove the ball. Anyway, he put 3 stakes out, like 100 yards out, 300 yards out, 800 yards out, 3 stakes at the same level, and he then took his camera and focused or showed that as the distance went on, there was no refraction. And then you just carry that line onto your distant 50 kilometers, whatever it was, away. I think it was more like 8 or 9 miles across a lake or across a river. It was proof that there was no perspective. There was no bending up as you went out with distance. So it's little stuff like that that will revolutionize this whole science as we go on.
Yeah,
and
not only that, yeah, you can't have it both ways. You can't have boats disappearing over the curve of the earth and then buildings appearing up out of the curvature of the earth. You know what I mean? You can't have best of both worlds.
Exactly.
I mean? So that
yeah. The way I like to say is you can't stand on a beach, watch a ship go over the curve, and then come back and say you have to go to 50,000 feet before you can see the curve. And that's essentially what they're doing.
And that's because they're not thinking properly, is it? They're just only reciting what they think is the truth.
They're reciting what they believe is the truth and what they want to believe. It really comes down to, are you willing to get rid of your belief system? That's one of the questions I've really thought through is why are people so antagonistic towards looking at this science and realizing that they've been told a lie? And there's several different reasons. Or why do people continually come back to flat earth videos and then leave you some kind of troll comment? And it's because they're not sure, really. They're not sure of themselves. I've lately, with people that I ban, which is a lot, ad hominem especially, you're an idiot or you don't know what you're talking about. Goodbye. You're not coming back here again. That's not adding anything to the conversation.
Yeah, I'm a bit like that now. I haven't got time for all that.
Exactly. As people, Crow XE, that's why he was never banned. He was never that way. He presented evidence that he thought, supported his side, which I totally respect. So somebody like that never gets banned. But, but I go to these people when I go to ban them, I look and see what their playlists are. And invariably, 50% of them will have 10 videos in a playlist debunking flat earth. It's like they don't do anything themselves. They go to other people's work, and you've seen these debunking videos. They're horrible. If you stand on a ball and you go 1,500 kilometers south, turn left, go 1,500 kilometers, turn right, go 1,500 kilometers, you'll end up at the same point. Well, yeah, you will if you're on a ball, but how many assumptions you just made?
And not only that, Bill Nye, when he says, why can't I see mainland Spain from the east coast of America? You know what I mean? Most stupidest response.
So if I was a scientist, supposedly as he is, I'd be embarrassed by not knowing that answer. Why you can't see, so far because of atmospheric conditions. It's just unbelievable.
Exactly. Just think how many different weather systems are taking place between there. You know what I mean?
Yeah.
Can
absolutely.
I just say that Skyfly's joined us? SKYFLYBRI.
Hey,
Hi,
you all right, Brian?
Hi, Karen. Thanks for the invitation. And hi, Dave. Hi, Richie, Patricia, and Astral.
Hello there.
Darling.
Welcome.
Thank you.
Hi, Brian.
Hi there, mate. Dave, I'm really interested in your observations of the moon. You've obviously put a lot of work into that. That's amazing.
Cheers, pal. Yeah, like I say, I've been observing it now for, coming up to 3 years, you know what I mean? So I've tried to concentrate just on that aspect of things. And I found that you get further if you're just concentrating on one thing instead of trying to concentrate on 10 different little things, you know what I mean? I never seemed to get anywhere when I was doing all different kinds of research or different parts to try and find out answers. But I've definitely got a lot further just by concentrating on solely the motions of the moon. You know what I mean? It's just opened up more and more doors. More and more observations I make, I can start questioning more and more things, like Kepler's law. Who would have thought you could question Kepler's law with a camera and a phone app? You know what I mean? It's surprising what you can get out of it when you put the time in it. So yeah,
it's very interesting to hear that it speeds up and slows down. What do you think causes that? For what reason?
What other reason could there be apart from electromagnetism? I mean, I'm just going by that, yeah, because I believe that the sky is electric, yeah, like a luminiferous substance, and basically it's a propagator of light, and all it's doing is passing them light from one circuit to the other circuit. Yeah, all the lights in the sky. I'm not just talking about the sun and the moon. I'm talking about all the stars and that as well. Yes, there is some weird shaped objects up there. And do I have the answers to why Saturn has rings? No, I don't. But you know what I mean? I'm just, we're all in this together and we don't have all the answers to every question. So I'll be upfront and say, well, why does Saturn have rings? I don't know why Saturn has rings. Yeah. It acts different to a star. So there is something different about wandering stars or planets or whatever you want to call them. There is something definitely different about them than there is with normal stars. So in regards to stuff like that, if I don't have the answers, I'll just tell you I don't have the answer to that. If I do have a theory on something, I'll tell you it's a theory or my hypothesis. I'm not saying that the Luna-Lema is the answer. What I'm saying is I've built this hypothesis from the back of my observations. Yeah, that's all I'm saying.
Yeah, what you said about you can't see stars through the moon, I agree 100% with you. I've personally taken pictures of the moon with a crescent moon, a half moon, and the bit you can't see is actually there, and you can't physically see through it. And if you overexpose the picture, you can physically see that part of it.
Which I've shown on many occasions, and I've also shown Aldebaran go behind the moon and not appear till it comes outside of the shadow bit. But like I say, there is a lot of people saying you can see it. You know what I mean? Let so be it. But I will stick to my guns on that until I have actually observed, seen the light of a star through the shadow part of the moon. I'm not going to say you can see it because I never seen it, and I've been out looking at the moon for like nearly 3 years. Religiously.
Well, they've got those stars have got to be in front of the moon then.
well, they always go behind. You know what I mean? The only planets or whatever what go in front of objects is when you get transits on the sun from Mercury and Venus. That's the only time objects pass in front of celestial objects, and the ISS will pass in front of the moon as well. So,
David, what I've done as I was watching the program, because your friend in Tasmania didn't get a great photo of the moon. That's what I've done. I've run a simulation of the moon dated on the 17th of the 11th, 2016 at 1955 GMT. And I've done a comparison where I've got a photo from Tasmania and one from the UK taken at the same time.
That's cool.
So I've got the picture available to show, if that's okay, Karen.
Yeah, that'd be cool.
Yeah, do you know how to screen share?
I certainly do. I've already got it open. I'll click screen share.
I'll just move it away just in case.
That's okay. Don't worry. I've done it hundreds of times.
Cool.
I'm sharing. These are the pictures I've taken. Actually, it's quite small, isn't it?
No, that's cool. Yeah, that looks all right. Yeah.
So the Tasmanian pictures on the left, it's basically 1955 GMT. Obviously, it's different. It's probably 10 hours, isn't it?
Yes, I think it were. Yeah, it was. It was something like, I can't remember what time it was, but
and that's why you've got a different illumination here in the figures from this side in the UK. Is that full screen? I can't see the watch space.
It's good. You're good.
Yeah, that's good.
The reason they're different sizes because I had it different zoomed. They're not that different in size. Just how I had it zoomed on the simulation program. So the sizes aren't much different, but you can physically see there is. I'm guessing. Oh,
it's a 180, isn't it?
This is it. This is Taco here, isn't it? Can you see my mouse moving?
Where's your mouse?
It's moving, but it might not show up because it's really
No, I can't see it. Are you on the right or the
I
left?
can see it. I can see it. It's down the bottom on the UK one.
Yeah, on the UK one, that's it. And I think it's up here at the top, which would be like 11 o'clock, but like 3 or 4 degrees in there.
Yeah.
But there's well, let's take this pattern here. I think that's the Sea of Tranquility from memory, and that appears to be there. Obviously, you might not see my mouse moving. Sorry about that.
Yeah, we can see it. Yeah.
Oh, okay. So there's definitely a difference, isn't there? Obviously, the size. Don't worry about the size. That's just because I had a different zoom.
Yeah, like I mentioned before, I don't know if you saw my demonstration where I try to explain field rotation from opposite sides of the hemisphere, where it's rotated to the observer's perspective. You know what I mean? Whereas an observer would have to turn around 180 degrees. Yeah, but people think the moon's spinning like a coin, but it's actually just due to perspective. And unless it was exactly the right position for each observer, we wouldn't actually get that perfect 180 degrees flip. Yeah, unless we was at the exact same points, if you know what I mean. But you can see it's rotated slightly further on his. Yeah, because you can see Tycho crater there. The like.
I can't see where you're pointing, but yeah.
Yeah, where that bright spot is in the where you pointed to first.
Yeah,
you know where? Yeah, around about there. Yeah, that's Tycho. Yeah. So
you know, Dave, that would be interesting to have two people 180 degrees away from each other take a picture of the moon at the same time and compare, just to make sure, instead of assuming that it's perfect.
Yeah, like I say, it's difficult because obviously he was in Tasmania, Australia. Yeah, it's not only the furthest point away, but it's probably the furthest point away in every direction you could probably go. You know what I mean? Right. And it all depends on the time of the day, because at certain times of day that moon's rotated to his perspective. You know what I mean? If it had been, say, if it had been early on in the day, the moon would probably be more tilted to his right or clockwise, counterclockwise to him, because it rotates the other way in the southern hemisphere. So,
what about somebody on the same longitude, but you at whatever you are, 50 degrees north or 48 degrees north or whatever you are, and somebody, like I said, on the same longitude at the same point south?
Yeah, well, it'd be rotated to their perspective. You know what I mean? So I might see the moon shadow perpendicular to mine, but that other observer might see it tilted further to the left or to the right. You know what I mean? It'll be rotated to their perspective. It won't be in the same position, because I did have a theory that when the moon's at zenith, that the terminator line or Tycho is always perpendicular with the ground. That's not the case. When it's at zenith, it's in slightly different rotated in its phase. So there's not a particular point at zenith where that shadow is straight down. It is the majority of time, but as I've shown in various hangouts before, that's not always the case. And Tyson Vanderbilt is the one who pointed that out to me about a year and a half ago. So thanks to him for showing me that, because my video says, yes, it is always perpendicular. And he proved to me it wasn't. And when I look back to verify it, he was correct. So that was a good point there.
I'll stop screen sharing now. I think we've all seen it, haven't we?
Yeah, thanks for that. It's good that, because like I say, it's a shame he hasn't got a Nikon Coolpix P900. He's got a Nikon whatever. Yeah, so it's not a very powerful zoom camera in itself, and plus it was plagued with high altitude clouds and it was daytime, so it was difficult to capture the moon, but it was a good effort, you know what I mean? And I believe that he shot that moon because we actually talked about it as we built up, and as I showed in that at the end of the actual Facebook thread, I actually included that link where we built up, where we agreed to do this moon sync, and it all built up from that point. So that was good to capture that as well, because we can see where it's happening. You know what I mean? So
yeah.
Can I just add, in the back chat there, I've put a few pictures of the moon with their Latin names. You know, we've got the Sea of Moisture, the Sea of Clouds, we've got the Tycho, the Sea of Vapors, which is Mare Vaporum, and you know, they're all labeled. They're all
all from the Jesuits.
yeah. But these are the names that we have. Africa. Who gave us the name Africa? Who gave us the name America? Who gave us the name Europe? Who gave us, you know, we have names, haven't we? And we know where these names belong to. It's the same with the moon. We have names. We know where the names belong to. And I've put these pictures in the back chat there so we can see, you know, there isn't only Tycho Brahe's crater or whatever, you know, there's loads of them, you know, and they've all got names. All of these craters, all of these little dark spots on the moon have got names. They've all been named. And I just put it in the back chat there so that people can see anyway.
Thanks, Astral.
No problem.
Thanks, Astral.
That's great work.
Rich, is there any more questions you've got, like you wanted? Because obviously, yeah, you got any more things that you wanted to ask Dave?
Well, we should probably be in contact since we're going to be together soon here.
Hey.
Yeah, definitely. I'll tell you what I will do though, because I was just about to show you that about the sun and the moon, weren't I, on the full moons? Yeah, how the actual moon mimics the sun on the opposite latitude when it's full.
Go on then. I've moved the camera now.
Right, let's make sure I've got everything right. I'll slide that one over there. That's it. So I've got the sun, I've got the moon. Right, okay, right, I'm ready. So if I share this screen now, application window. Right, is this screen on me?
Yeah, you did it good that time, Dave.
Thank you. So what I did, I just got a list of the full moons here. So I got the first one on January the 1st. And as you can see, I've gone to January 1st from my location. And looking at that, you can see the moon is visible for a long period of time. So that tells you that the moon is high on the Tropic of Cancer. So there you can see, look, so it rises at 4 o'clock and it's visible right through till 7 o'clock the following morning. So it's visible for quite a long time. As you can see, it goes that way, picks up there and goes right around there. So that's the moon high on the Tropic of Cancer. When you have a full moon high on the Tropic of Cancer, the sun is always in the opposite latitude, in the opposite hemisphere, always. And what it does, it mimics the actual latitude. Well, the moon mimics the latitude of the sun in the opposite hemisphere, but it's always 5 degrees out. I'll show you what I mean by that. So as you can see, the angle on the moon is the sun is quite steep, but the sun is always low on the Tropic of Capricorn when the full moon is always high on the Tropic of Cancer. So if you go to the next full moon, what I'll do, I'll miss one out and I'll go to March 1st. We don't need to go through them all. So we'll go to the full moon on March the 1st. There you can see the full moon. It says it's a full moon, but it's only 98%. So let me just try March the 2nd. That's better. We'll go to March the 2nd. There you can see the full moon. You can see that angle now. Obviously, the moon is obviously further south, so it's visible for less time. You can see there, look, it rises at 6 this time and sets at just at 7 o'clock. Now, if we go to the sun on the 2nd of March, you'll see the sun matches the moon on that latitude. It mimics it. They're always in the opposite hemispheres. So then we'll go again to the next full moon, which is on, say, April. We'll go to April 29th. (29th). 99.7%, just about a full month. As you can see now, it mimics the sun, yeah, but I haven't changed the sun yet. So when I go to the sun on 29th of April, it'll be on the opposite latitude then, because they're never in the same hemisphere together. What was the date again? Sorry, 29th of April, right. There you go. It's a little bit steeper angle, but you can see they're never in the same hemisphere together a lot. And it always mimics it. So I'll go to the next full moon, which is...
Do they come together in the hemisphere when they say a new...
They do on a new moon. That's the only time they're... Yeah. On a full moon, they're never, ever in the same hemisphere, ever. Even when you get to the one what's on, I'll show you the one for September, which will give you probably a better idea where they're like super close, but they're not quite there. In fact, the one in March might be the better one to show you, actually. So,
But the thing that's crazy about that is how you can have that 24-hour moon
31st. Yes, I know it is.
in both summer and winter.
Yes, I know it is. Yeah, it doesn't matter. It doesn't affect the sun. The moon still does what it does. Yeah, throughout its cycle, regardless of what the sun does. So I think it's March 31st.
That's pretty good, Dave. You know the full moon's right off the top of your head.
So you can see it's quite close on that one, isn't it? Yeah, this will be interesting, this one. So go to March. Yeah, as you can see, even though it's on that line, it's just a fraction below it. That's probably the closest you could ever get it to being with each other. Yeah, you have to get the exact full moon, because what this does, you see, it doesn't change when that line across there doesn't change when you move this bar across. So unless you can get the actual full moon, which is actually somewhere around there, as you can see, look, it's only full for a fraction of the time now. But what you will see, I'll give you another example now for one more, which is like, say, October 24th.
I mean, this shows me we should have a lunar eclipse every month.
Yeah, it's strange, especially the one in September, because they're both in perfectly line with the ecliptic. They both draw a straight line.
Is there an eclipse then?
That I don't. There's not one set, but that's why I'm going to get my camera ready just in case something happens. I'm not expecting it to, but I'm going to be at the ready, kind of thing.
Gotcha.
My question to you, Dave, or to anybody, is this: what is the significance with September 23rd?
And there you go again. Look, they're in that opposite. Even though the sun angle is a little bit sharper, it basically mimics it. If you can see them step by step throughout the year, the full moons, and the sun position at that time, it basically mimics it on the opposite hemisphere. As it gets that southern declination, the moon, and the sun gets the northern declination, there's then a crossing point, and then obviously the sun's heading up high, and the full moon's heading up low. Remember, I'm only referring to full moons here. I'm not referring to any other moon apart from it being full. But it's interesting, like I say. And when you look at the one in September, now they're telling us it's the 23rd. Yeah. So I'll go to sun calc first. So I'll go to the 23rd. And you can see that line there is not perfectly straight, is it? And if you look at the rise time there, 6:18, it's setting at sunrise, 6:51. And it's setting at 7:01. Now that's not right, so you need to go to probably the 24th or even 25th for that line to be perfectly straight. Then you get 6:56 and 6:56. See sunrise, 6:55, and it's set in at 6:56, which is exactly 12 hours. So the equinox is actually on the 25th, but they're telling us it's on the 23rd. Now that there is pretty good proof to prove that. And if I just go to September here.
Well, hang on a second, Dave. Would that make any difference from being in the UK? For example, if you was in Florida?
Now, I'll show you then in a minute, and you can see. Now as you can see, look, that line is a little bit down on the moon because it won't adjust it. It just does it for the set time. But if you could change that time there, somewhere along that line would be straight and it will be perfect line. So they're both going to be aligned with the ecliptic. Yeah.
On September 25th. So there should be an eclipse.
There should be an eclipse, but but we shouldn't even see the moon if you think about it. If the moon is a ball of rock in the sky and the Earth is between the sun, how can we see the moon? It should be blocked out by the globe.
I agree.
Yep. So that's just a little bit more on that one. You wanted to see it from a different latitude, didn't you? It may change slightly. I'll go to somewhere pretty far. So, oh, this is a moon. I need to be doing it with the sun, don't I?
You know, like if you was to go to Florida, for example, like I said, what would that bear reading with those readings?
Let's have a look.
Astral, I think Florida's about the same latitude as UK.
I'll go a bit further down to Mexico then.
Yeah, Florida's about the same as UK.
Yeah. So there on the 25th, obviously it's rising at 7:34 and it's setting at 7:38. So it's you know what I mean? It's within reason. Like, it's not the perfect thing. It may, obviously with the time difference there, it may actually fall on the 24th. You know what I mean? Yeah.
That's another stupidity of irregularity. I mean, if it's a spinning ball, it's got to be the exact same time no matter where you are.
Exactly. So, but it is interesting. Like I said, when the moon's aligned with the sun on the 25th, 24th and 25th, obviously with the time differences, I think the actual the full moon, when it's at 100%, is actually on the 24th, and it passes over into obviously the 25th for me. But from like from earlier places, it's going to be the 24th. So probably about 11 o'clock at night, I would imagine.
Dave, I have one last question. If we can help in any way on the 23rd, 24th, 25th, what could we do? If we was to do an experiment like many people, I mean,
well,
across the plane, how could we help you in your researches, or how could we help each other in like observations and what have you, you know, you understand what I'm saying? What can we do?
Well, what I would do is prove mainstream wrong, and if everybody got like a phone app with the either diopter or theodolite on it, and what you did on the 23rd, you got the sun rising, and you showed that it's not rising at 90 degrees and it's not setting at 270, yeah, and you measured the time of daylight, and proved that it's not equal days like the true equinox. Then if everybody did it, then you know what I mean, you've got a bit of a case to answer. But when you've just got the odd few people doing it and shouting about it, it doesn't really get anywhere, does it? You know what I mean? You need more people to be on board with this kind of research. This, you know what I mean? But these are things you can find out yourself. You know what I mean? I know you're looking at time and date and moon count, but what other choices do I have to base anything on? I can't base it on anything else apart from mainstream figures.
No, but that's exactly my point. We're not basing it on anything. We're basing it on truth, what we're seeing. And that's what I'm saying. On the 23rd, 24th, 25th, when the equinox is, if we can take readings, like, would it be good then, if I presume, we can see the sun is coming up and it's at however many degrees it is. And now I can see the sun's taking its path and it's going down. It's like 270 degrees west. That's where the sun went down. And if everyone makes a reading of where the sun came up, if they're able to read with a compass, obviously point north to north, see where the sun's coming up, and then find out where the sun's going down later on in the evening, would it help us in anything in any way?
If you've got a camera, find out when the 100% full moon is. It'll tell you on time and date, and get your camera ready to shoot that moon at 100%. I think it starts on the 24th. It'll probably be the 25th for us in the UK. Yeah. And shoot that moon, and then ask the question, how the hell am I shooting that moon when the Earth's blocking it out from the sun? You know what I mean? Because they're both aligned with the ecliptic. So that's my question. How are we going to be observing the moon if it's a rock and we've got a big ball blocking that light, that sunlight?
I've done a test with that, Dave. I checked midday. I used the meridian, so 0 degrees, and the sun obviously directly overhead, and the moon's 100 miles to the left of that. So that would be the left would be which way? Back to front, isn't it? I can't remember, east or west. I'm not sure. But I've done that test, And I thought, this is it. I've nailed it. I've nailed it. I've finally debunked it. And then I done a CAD drawing and moved the moon to that ridiculous distance they told us, and you can physically see the sun, a direct line to the moon.
Don't forget that moon's only got a 5-degree inclination.
Yeah, I've done all that. I've done it in CAD. Even though it's 100 miles from the center of the ball Earth, it's still physically viewable by the sun at that ridiculous distance.
Well, like I say, I'm not very good at modeling and things like that. I'm just going by what I believe should happen. You know what I mean? It's like I'm just trying to imagine a big ball Earth and a ball of rock in the sky. Yeah, you look how big that moon looks from our perspective. Yeah, and then they're telling us that they're both pretty aligned with the ecliptic, and yet nothing's going to happen. You know what I mean?
I think it was Jeranism. He said, how can you physically see a full moon during the day? And so I done some tests, and you can physically see it at certain times of the year, depending on what latitude you're at.
Well, you should. I'm not sure if you'd be able to see it on this this equinox, because, you know, if you're quite...
No, not this time of year, no, September.
Yeah, but if you look at the moon rise times in the far north, you'll be surprised, because it's actually rising less than an hour a day instead of like 24 hours 50 minutes. Yeah, so you know what I mean, and that's over like a 3 or 4 day period. So over 4 days, yeah, the moon's lost what, say the mean time's 50 minutes, 50 times 4, that's 200 minutes. That's a long time.
I know,
You know
it's
what I
really messes your head up when you get into it.
That's
Really
3 hours. It's lost 3 hours somewhere on the line. Yeah, the other times of the year, it's going to be doing its normal mean time of 24 hours, 50 minutes. So something's happening.
Yeah, we've all been programmed with that ball Earth.
Exactly.
We've got all that information in our head, so we always compare that with what we're physically looking at. Even though we know it's not that, it's hard to get away from it, isn't it?
Yeah, that's one of the first things I said about becoming a flat earther. Try and make sure you get the globe out of your head first.
Yeah, definitely.
Yeah, people still accidentally say it. They just say it in a sentence.
Is it
They don't
me,
mean- they don't
or
mean
is
to, they
everyone
just say
sounding like
planet.
Alex tonight?
No, we're fine. Can I just say that we've been going for 3 hours now. Is there anything else we want to talk about today? Because obviously Rich says that he's going to get you'll get in touch with each other now, and
Yeah, definitely. Like I say, if we're both in the conference, I don't know why we can't kill 2 birds in one stone and maybe put our heads together and get something going. Like,
yeah. Oh, Rich, you're muted.
What I'll do is I'll contact Robbie Davidson and see if he's okay with us combining forces.
yeah, I mean, I can't see why Robbie won't, because Robbie did actually ask me at the convention if I'd do a workshop at the conference, which I'd agreed to do, like, because Robbie seen my presentation in the hotel room, and he says, well, yeah, that's pretty good. He said I won't mind you doing something like a workshop, because I think he just had the idea about the workshops then, like, you know what I mean?
Right.
So yeah, definitely. See what he says.
Yeah, it'd be an honor to work with you.
Cool. Yeah, I look
Aw.
forward to working too, Rich.
Flat Earth at its best. And friends being made, friendships being made. It's great.
Yeah, Flat Earth is the only place where you can go anywhere, meet anybody, and stay at anybody's house. Because, like, when I went to Speaker's Corner to do some street activism, yeah, you just basically turn up at some stranger's house, you get your head down, you sleep, you get up, you have a shower, you know what I mean? You talk like you've known each other all your life, then you go and do what you're going to do, like, then you come back to the house and you have a few beers, and everybody gets on with everybody, yeah, even though you've never met them before. It's the only thing you can, you know what I mean, you can do. You can, like, you've got friends all over the place. You can travel everywhere for free. Like, well, not travel everywhere for free, but probably when you get there, you're not going to have to pay for accommodation because you know so many people. It's great.
Absolutely.
Yeah, and yeah, it's great, really great, and yeah.
I just want to say thanks, Karen, for the invite. It's been nice talking to you people. And
Yes, I'm here. Hi.
and Richie. I didn't get to talk to Patricia.
Is Patricia asleep again?
Patricia's she's got her son there, so
All
she's
right.
just she's been very quiet.
I'm here.
Oh,
All
hello,
right.
Patricia.
Hello, Patricia.
Hello,
babe. How you doing?
everyone.
and of course the Astral Thief.
I'm all right. It just
No, but it's good that we have these hangouts, and we're learning lots. It might be slow sometimes, but it's moving on.
It's so detailed. I mean, maybe it's not so complicated for Dave anymore, but I bet it was.
It is.
It's quite complicated. The whole thing, even listening to it, the amount of information.
Everything is complicated when you try and break it down, because nothing makes sense. That's the problem. You think you've found an answer to something, then something else jumps up. You know what I mean? It's something's always popping up. You think you've got something. Yes, I've eureka moment. Then, oh dear, back to square one. So it's like I say, it's a long process, and the more you try and research one thing like the moon, the less you seem to know about it.
It's all a learning curve. Just that apogee, perigee, probably
Aphelium, perihelium.
Yeah, exactly.
Yeah, they have different names for
3
different
years
bodies
ago,
as
Dave.
well. For the
2 or
sun,
3
it's all helium, so it's perihelium and aperihelium, and then you have a different one for any objects that orbit the moon. It's another name for it. So there is. I did once know all the names, but I've forgotten them all now. But yeah.
It's basic stuff, isn't it? Once you know it, you know it. It's like how broad is it? How wide is it? How high is it? How tall is it? You know, we know these terms, and it's the same with moon and with what we're dealing with and everything. But maybe like 4 years ago, you didn't have a clue about what apogee and perigee and all these other terms and.
Yeah, always learning.
Nowadays.
Always learning.
Everything I've
Nowadays,
learned has been in the last
tell
3
it all.
years.
Relearning, actually. Rich, as we're at the end, do you want to have the last word?
Well, Dave, first of all, thanks for coming on, and I enjoyed it thoroughly. I just dropped my email in the group chat.
Yeah, I've just seen it.
Okay. What I'll do also is once I hear from you, I'll send you something. Probably what I want to cover. I'll make sure we don't, cover the exact same thing or whatever. I want to get into some of the light atmospherics, different things like stuff we can discuss later. Yeah, I thoroughly enjoyed this. Thank you so much, and thank you for posting that video. There's going to be more on my channel from your video. I just haven't even had a time to go through all of it yet. But yeah, great work.
Yeah, I could see you thinking, Rich. I could see your mind going.
Yeah. Thanks, Rich. And like I say, I'm glad that somebody's actually acknowledged the amount of work and effort. Because if you knew what I've had to face to put that presentation together, it's been like probably the hardest year of my life. Yeah, from the beginning of this year to this point now. So just to have that appreciation and understand that, I've been through hell to get to this very point now, and what I've done in between that is like I'm proud of myself, because I've accomplished things where I probably never ever would have done under normal circumstances. I really had to dig deep to get to where I am now. So it is a pleasure to be appreciated for the work I've done, whereas other people haven't seemed to have noticed any of my research or any of my observations.
But that's a shame, because it's top-notch work. It really is.
Yeah, Dave, I'm a fan of yours, don't you?
There's nothing. There's
Dave
nothing. You know what it is?
He's
There's
lovely.
nothing like real science and real observation, and you've done that.
Yeah, like I say, it's just just observe, measure, and record. That's all you got to do. And like I say, it's the more you do it, the easier it becomes. You know what I mean? Like I say, my first observations were poor. If you watch my very first moon race video, it's horrible. But like how it's evolved, how I've evolved, how the equipment's evolved, how I use the equipment's evolved. Everything's evolving all the time, and I'm learning new techniques and learning new tricks, and I'm learning new knowledge all the time. So it's been a quite a steep learning curve, but it's worth it. And recommendation for books, I definitely have a look at that book, Ether and Gravitation by William Hooper. Forget about the gravity bit. Just concentrate on the first 20 chapters, which is all based around electromagnetism and ether, which is a brilliant, brilliant read.
I've just realised my photo shows bendy water. Obviously, that's a GoPro camera. I can assure you it's very flat, even at 10,000 feet. And that's
bendy water.
I just looked at it. I thought, that looks curved. But that's just a camera. It's just a camera.
Yeah, obviously it's a fisheye lens there you got.
Yeah, we understand barrel lens distortion.
Can I say that we say goodbye off air to each other on the panel, but say goodbye on air to everybody? And I'd like to thank everybody in the chat room. Who's quite a lot of the people there have stayed for nearly the whole hangout, I think. So thank you so much, everybody in the chat room. Mwah! Good morning, good afternoon, and good evening.
Goodbye.
Thanks for watching.
Thank you, Skyfly. Thank you, Astral. Thank you, Patricia. Thank you, Dave, Marsh, and thank you, Mr. Thrive and Survive, Rich.
Yeah, and I would just like to reiterate exactly the same. Thanks, Dave. Thanks, Rich. Thanks, Patricia, Skyfly, and you, Karen, and everybody in the chat. It's been brilliant.
Yeah, very good talk.
I've enjoyed it. Like
Really
I say,
glad.
if anybody wants to get in contact with me, you can either get in contact with me through Facebook Messenger, through my email address. I'm sure if you want it, just drop me a message. You can either message me through.
I put obviously yours and Rich's channels on the description, so they can get to you that way on a link, can't they?
Yeah, like I say, Karen, if anybody wants to get hold of me, you could just forward my.
Yeah, you can get in touch with me, and I will forward them to Rich and Dave.
Yes,
anyway,
it's been fun, and I've enjoyed it.
Anyway, yeah, thank you so much.
Before you go, Dave, can I just ask you? Is it? Are you on any other platforms like BitChute or Gab or Real Video or anything? If you're not, maybe you should upload a video or two just to have something, because maybe one day, maybe YouTube will never exist, and if we've got other platforms with. Do you know what I'm saying? A backup. I've
got every single one of my videos on my computer, so I don't have to worry about it going down. I just hope the computer hard drive doesn't go down. So, but like I say, I'm on Facebook. I've also got my own Luna page, which is Luna Cosmology Research, so you can have a look on that. I've got my YouTube channel. I've got Instagram.
Yeah, and Facebook channel.
And Facebook, yeah. So, and I've got the group Flatline with 3,500 members in as well. So,
yeah, thank you very much. So, me or any of those things that Dave said, and again, thank you so much to everybody. Mwah! To everybody.